Hello everyone, welcome to the paper discussion of the full test paper 9. Let's go with the first question, physics part. So first question is saying one end of the uniform wire of length L and weight W is attached rigidly to a point in the roof and a weight W1 is suspended from its lower end. If S is the area of cross section of the wire, the stress in the wire at height 3L/4 from its lower end will be. Now to understand this, we just need a simple free body diagram of it. So if this is the fixed location, let the wire be over here, up to which there is a block of some weight W1. Of some weight W1 is attached. We wanted to find the stress at a location that is 3/4 of the length from the lower end. That means somewhere over here. So if I split the wire at this location and divide it into two portions, the free body diagram that I can draw over here will experience some tension. That tension will be because of the lower portion of the object or of the wire in the upward direction. And this tension will be absolutely because of the portion of the wire, because wire has some mass, some weight W. So the bottom portion will be 3L/4. That means this will be 3W/4 plus the weight of the block W1. So thereby here the stress will be equal to force upon area of cross section. The force will be the tension in this case. So that will be 3W/4 plus W1 whole divided by the area of cross section. Here they gave it as S. That will be our answer, W1 plus 3W/4 divided by S. That will be option C. Okay, let's go for the next question. Particle has acceleration given, okay, and then due to magnetic field is available, they are asking us to find the value of alpha. Now, whenever a charged particle that is entering a magnetic field, that will have an acceleration in such a way that the particle will go in a circular track. Therefore, the acceleration will be centripetal in nature, while the field is perpendicular to that centripetal acceleration. That means we can say the dot product of this acceleration and field vector must be 0, because these both are perpendicular to each other. As a result, if you just do the dot product of it, so 6 into -3, that will be -18, plus there is no j cap in the acceleration part, there is only k cap, that will be 2 alpha will be equal to 0. That's all. So 2 alpha is equal to 18, or alpha will be equal to 9. Okay, that will be option C. Next question. Particle moves with xy in xy plane. According to the equation, position vectors are given. X is equal to kt and y is equation position vectors kt into 1 minus alpha t. And then k and alpha are constants and t is the time. Time instant when angle between acceleration and velocity is 45 degrees. First, we will calculate the velocity and acceleration vectors. So if I differentiate x with respect to time, I'll get Vx. That will be equal to k. That if I differentiate again with respect to time, it will become 0. That means ax component is 0. Similarly, vy component, that will be kt minus k alpha t square. So that will give us k minus, differentiate that, it will become 2k alpha t. On the contrary, ay, if you differentiate this again with respect to time, you'll get it as minus 2k alpha. Now the point here is these both the velocity vector and the acceleration vector must get at an angle of 45 degrees. So the net acceleration vector, you can observe it is along the negative y direction like this, and velocity vector is at a 45 degree angle. Okay, the only possibility for these two things will be at 45 degrees is when the y component, when the y component of the velocity vector and x component of the velocity vector are equal. If these both has to be at 45 degree to each other, it is only possible if Vx component will be equal to Vy component. So Vx component is k, of course it should be negative of that y component. So this will be equal to 2k alpha t minus k. So it will give us 2k is equal to 2k alpha t. 2k will cancel. That will give us the t value as 1 by alpha, and you have your value as option B. Okay. Just a minute. Let's go to the next question. Question number 4. In the system shown, block A is moving towards the right side, okay, but it has a velocity as a function of time. And then block C is also moving towards right side with constant velocity 4 meter per second. And then velocity of the block B at t is equal to 4 seconds. So we can do this by using the simple constraint relation. I'll use the constraint relation in the method of energy method, that is summation of dot product of tension and velocity must be 0. Okay, so what I'll do, I'll consider that the object B is going down with velocity Vb while it has a tension T upwards or T1. Here block A tension is in this direction, block C tension is in the opposite direction. So if I write the constraint equation now, it will be T times VA minus T times VC minus T1 times VB must be equal to 0. But however, this pulley will relate us the tensions of the T and the T1. From there we can get 2T is equal to T1. So this T1 place I can just rearrange it as in terms of 2T. So this will become VA minus VC minus 2VB is equal to 0, or 2VB is equal to VA minus VC. So what is VA? At 4 seconds of time they are asking. VA is given as 2T. So it will be 2 into 4 minus VC is given as 4. So this will be a total of 8 minus 4, that will be 4 meter per second, or VB shall just become 2 meter per second, which will be option B. Let's go for the next question. Question 5. Which of the following does not have the same dimensions? Well, it's a pretty straight one. Work and energy, they have same dimensions. That will be joule. Units will be joule. Angle and strain, they are unitless and dimensionless. Relative density and refractive index, both are dimensionless again. Force and energy are the things that are having not same dimensions, because force units will go with Newton, whereas energy will go with Newton meter. That's why these both will not have same units, neither they will have same dimensions. Question number 6. For the circuit shown in the figure, value of the resistance R is adjusted so that the power delivered to the resistor R is maximum and is equal to P0. Value of P0 is. Value of P0 is what they are asking. So they have mentioned that the power through this particular R is maximum. Now using the maximum power transfer theorem, we can clearly understand the condition is net external resistance must be equal to net internal resistance, or power, maximum power, if it has to pass through a particular given resistance R, then its value must be equal to net internal resistance. So from here, the internal resistance is 6 ohms and 3 ohms, both are in parallel combination. Let us analyze the internal resistance equivalent value. Both are parallel, so it will be 6 into 3 divided by 6 plus 3, that is 9. So overall this will give us 2 ohms. So therefore the external resistance value must be equal to 2 ohms. But how will that solve our issue or solve our problem in this? We wanted the power value. Now if I want to know the power value P0, I can simply calculate this by using the equation I square R. R value is already known for me. I need to calculate the total current traveling in this particular thing. Now these two branches will be taken as one single branch with EMF some E equivalence, and then R equivalence. So how do we calculate that? Well, for that also we have an equation that will be E equivalence divided by R equivalence must be equal to E1 by R1 plus E2 by R2. So how much will this come? E1 by R1, I'll take it as E1 as 12, R1 as 6, so 12 by 6 that will be a 2. E2 by R2 that will be 1, so total this will be 3. But R equivalent is 2, so total E equivalent will be 6. Sorry, 3 into 2 that will be 6. 6 volts. Once we get the E equivalence, I need to get the total I. So total I will be equal to total E by total R. So this will be 6 divided by total R equivalence, internal resistance equivalence is 2 ohms, and then the external is also 2. So total that will be 4. 6 by 4, which is 3 by 2 amperes. Now I value I have, I'll substitute that back in this equation. So I square R, 9 square by 4, or 3 square by 2 square, 9 by 4 into R value is 2. So we have 4.5 watts. That will be option D. Okay. Next question. Find the charge on the capacitor in the following circuit. Well, if I want to find the final charge on the capacitor, then this particular branch in which capacitor is there, that must achieve a steady state. In other words, once the capacitor is completely charged, the overall current in this particular branch will be 0. This becomes an open circuit. So this circuit will transform into an open circuit with overall equivalent resistance 8 ohms with a 12 volt battery. Okay. So from here I can calculate. So what do I do with this is I'll first calculate the total current. So total current will be total EMF, that will be 12 by total resistance, that will be 2 plus 6, 8. I have the total current value as to be 3 by 2 amperes. What will I do with this total current? Well, since there is a capacitor branch over here, okay, and this particular capacitor branch will not have any current through it because it has achieved the steady state, but the potential drop across the 6 ohms will be same as the potential drop across the capacitor also. Okay, the resistance over here, the 4 ohms will be ineffective because there is no current passing through this middle branch. So what will be the potential across the 6 ohm resistance? V across the 6 ohm resistance will be equal to the current, total current, that will be 3 by 2 into the 6 ohm resistance 6. That will be a total of 9 volts. So the same 9 volts will act along the capacitor also. So total charge on the capacitor is its capacitance into the voltage. Its capacitance is given as 2 microfarad and its voltage across the capacitor is 9 volts. So total it will be an answer of 18 microcoulombs. That will be option D. Okay, let's go for the next one. Question number 8. For the circuit shown, magnitude of the potential difference across C and D. Well, this we can understand easily if I pick the path C to D like this across 1 and 2 microfarad capacitance. But before we do that, let us understand if you can get the potential across this, that will be easy, because if I want to calculate the apply the loop analysis or KVL, current law analysis, conserving the charge, I just need to know the total potential drop across each one of them. So for that I need to know their charges. So first I'll find the C equivalence. That means the upper branch 1 and 2 microfarad, they are in series combination. The upper branch will turn out into 1 into 2 by 1 plus 2. That will be 2 by 3 microfarad. The lower branch also will turn out into 2 by 3 microfarad. These two things combined together will be in parallel combination. That will become 4 by 3 microfarad. and this 4 by 3 microfarad is in series with this particular 1 microfarad. So total CE equivalence will become 4 by 3 into 1 divided by 4 by 3 plus 1, that will be 7 by 3. So total CE equivalence, we are having it as 4 by 7 microfarad. From this, I can get the overall Q value. Okay, I got the C total. Let me get the Q total. So Q total will be C equivalent, that is 4 by 7 into V equivalent, that is V naught. So I get the Q total as 4 by 7 V naught, which means this particular 1 microfarad will have a total of 4 by 7 V naught of charge. What is the potential drop across this 1 microfarad? Potential drop across the 1 microfarad. So I will mark this as X over here, and if this is V naught, then this entire thing over here also it will be V naught. Okay, so the potential drop across 1 microfarad will be V naught minus X is equal to 4 by 7 V naught, because potential drop across this will be charge by its capacitance. Charge is 4 by 7 V naught, by capacitance is 1 microfarad. So it will become, this will be microcoulombs in this case. Total 4 by 7 V naught. And thereby, what will be the value of X here? V naught minus 4 by 7 V naught. That will be 3 by 7 V naught. Okay, 3 by 7 V naught. Now what I will do is, I will start from VC. I will go across. So if this is, let's mark the potentials also. For this is the positive terminal, this must become negative, and these both must be positive on the other side. Okay, so if I start writing the equation for potential difference between the point C and point D, I can write it as VC plus Q across the 1 microfarad divided by its potential 1 microfarad, so its capacitance 1 microfarad, minus charge across 2 microfarad divided by its capacitance 2 microfarad. The balance will be at point D. Now my target is to find this charges across the 1 microfarad and 2 microfarads. How will I get that? Well, if I use a little bit logic, okay, the combination of all these things will be one capacitance that will carry the charge of 4 by 7 V naught, because in series combination, how much ever 1 microfarad carries, the same this entire thing will also carry. Now the capacitance of this upper branch and lower branch equivalently they are same. So the total charge will be divided into 2 equal halves. That means 4 by 7 divided by 2, that will become 2 by 7 V naught. So charge across 1 microfarad will be 2 by 7 V naught. Charge across 2 microfarad also will be 2 by 7 V naught. So this balance VC plus 2 by 7 V naught minus 1 by 7 V naught is equal to VD. Okay. So across C and D they are asking VC minus VD will be 1 by 7 V naught. That will be option D. Alright. So go through the question once again, you will have a clarity about what is happening. Next question, question number 9. Current I flows in the long straight conducting as shown in the figure. If magnetic field at the center of the circular loop is same, in the same plane is 0, then the current in the circular loop is. One thing we need to understand, this is an infinite wire due to which the magnetic field will be varying with distance. Okay, that means throughout this particular loop, magnetic field intensity is not same, it is varying. As the field intensity through the loop is varying, what will also vary? Flux will also vary. If the flux is varying, what will happen? The induced EMF will come into the picture. So as the flux is into the plane, okay, the field is into the plane and it is reducing. Okay, it is into the plane and reducing. So we will have a clockwise amount of current, induced current I, that will be generated in this particular loop. Okay, so we need to They are saying total magnetic field at the center of the loop is 0. That means magnetic field because of the I naught must have been equated with magnetic field because of the current I. Okay. Now magnetic field because of I naught. This is like infinite wire at a distance of d, whose equation shall be mu naught I naught by 4 pi, sorry, 2 pi d must be equal to magnetic field due to a circular loop, that will be mu naught I by 2r. That's all. Cancel the relevant stuff. I need the value of I, so I shall be equal to r I naught by pi d. R I naught by pi d, option D. Okay. Next question. Question 10. Two metallic rods, equal length, cross section, equal length and cross section, but thermal conductivities K1 and K2 are welded together end to end. The resulting thermal conductivity of this resulting rod will be. Well, this is pretty straight. It's a formula of K equivalence in series combination. The answer will be N by K equivalence for identical length and everything. It will be 1 by K1 plus 1 by K2. Okay, and so on up to Kn. So here there are two rods, so the equivalent value shall become K equivalent is equal to 2 times K1 K2 divided by K1 plus K2. This is a straight formula for series equivalence of thermal conductivity and parallel combinations. Next question. Question 11. Electron is accelerated through a potential difference of 10,000 volts. Its de Broglie wavelength is nearly. So for this, we know that wavelength, de Broglie wavelength can be represented as h by p. And this momentum, we can again write it as square root of 2 times mass into kinetic energy. Kinetic energy in terms of charge and potential difference, that will be QV. So here, this entire quantity of h by root 2m into the charge and the separate root v. This overall value, if we calculate, shall become equal to 1.27. Let's just calculate that value. I'm putting in the calculator. It will be approximately 12.27 angstroms divided by root v. And now they have given the root v value as 10,000. That will be, after taking the root, it will be 12.27 angstrom. That will be 10 to the power minus 10 divided by 10 to the power 2. So you will have 12.27 into 10 to the power minus 12 meters. That will be option A. Next question, question number 12. Two infinite parallel parallel sheets separated by a distance d have equal and opposite uniform charge density sigma. Electric field at a point between the sheets will be. Well, this is a pretty straight one. So this is one sheet and this is the other sheet. One is having a surface charge density positive, another similar but negative value. Now due to the sheet, it will be sigma by 2 epsilon naught. And this is a negative charge. For that also the field lines will be into it. That's again a sigma by 2 epsilon naught. Total electric field will be a combination of these both. So that will be a resultant of sigma by epsilon naught. That is option B. Okay. Next question. Question number 13. Gas is filled in an adiabatic container with adiabatic piston. When gas is compressed, its temperature change due to. Well, already the piston, when it is at rest, the collisions will be happening because of collisions between the gas molecules between the walls of the container. Now, as you are moving this piston inwards, more amount of momentum will be transferred only with the collision of the gas molecules with the piston alone, because with the gas and with walls already they are happening. So therefore the answer will be only because of the change moment of the piston over here. Next question. Question number 14. Electric field at a point P due to the long rod having a uniform charge density lambda as shown. This is a semi-infinite wire. For semi-infinite wire, net electric field is given as root 2 K lambda by R. Okay. So if you substitute in terms of values, root 2 by 4 pi epsilon naught lambda as it is, because the answers are in terms of lambda and the distance R is capital R. So 4 you can write it as 2 into 2. So you have the option 1 by 2 root 2 by epsilon naught lambda by R. That will be option B. Okay. Again, it's a straight formula based question. Next question. Question number 15. A particle is moving in a circular track of radius r with uniform speed, takes t amount of time to complete one revolution. If this particle is projected at an angle to the horizontal with the same speed, horizontal range is assigned to be 2r. The angle of projection theta is given by. For this, first the equation for projectile motion range will be r is equal to u square sine 2 theta by g. Two things are there. We know that the range is 2r as is given in the question. And u value is what we also do not have. Now they said the u is obtained from the circular motion. So we can have the u value in terms of time period. Time period is equal to 2 pi by omega. Omega I can write it as u by r or v by r. So this will be 2 pi r by u. So u value is 2 pi r by t. That if you square it and substitute in the equation, this will become 4 pi square r square sine 2 theta by g t square. Cancel the elements, 2 and 4 will go by 2 times. So the answer will be g t square r divided by 2 pi square r square. This r and r square, if you cancel, there will be only 1 r in the denominator. Yeah, this will be equal to sine 2 theta. That means you will have an answer sine inverse of this overall value gt square by 2 pi square r. 2 theta shall become 1 by 2 on the other side is equal to theta. That will be option B. Okay, let's go for the next one. Question number 16. Molar specific heat of a diatomic gas undergoes a process PV power 3 is equal to constant. This is a polytropic process. Don't mistake it for adiabatic. For polytropic process, molar specific heat capacity is obtained by using Cv minus R by N minus 1. Diatomic gas, usually Cv will be F by 2R. Diatomic gas, degree of freedom will be 5. So there is a 5 by 2R minus this is R by N value is 3, 3 minus 1, 2. So that shall give us 4 by 2R or 2R. Option A. Next question, 17. Displacement equation is given of a simple harmonic wave, maximum velocity of the particle. Well, particle's maximum velocity is omega into A. Omega value, compare it with the original equation, omega t, so that one will be 2000 pi. But A value, don't take it as 10 by pi as it is. Please look at the units. They are in centimeters. So into 10 to the power minus 2. So that shall give us, there is a 4 zeros and this will be 2 zeros. Balance 200 meter per second. That will be option C. Question number 18. Ray of light passes from vacuum into the medium of refractive index 1.5. If angle of incidence is twice the angle of refraction, then the angle of refraction is how much? Well, it is passing from air. I'm using the Snell's law. So 1 sine incidence angle is 2 times the refraction is equal to 1.5 into sine r. Well, this sine 2r I can write as 2 sine r cos r. That will give a balance of 2 cos r is equal to 1.5, that is 3 by 2, or r can be taken as this will become 3 by 4 and then cos inverse 3 by 4. Option C. Question number 19. Double convex lens are made from the glass of refractive index 1.55. Both faces are same radius. Focal length of the double convex lens is 20 centimeters. We need the radius of curvature. Convex lens. In the lens maker's formula, we have 1 by f is equal to mu, refractive index of that medium, by refractive index of air minus 1. Always remember it this way, into 1 by r1 minus 1 by r2. So if I draw the lens, usually we will consider this to be R1 and this to be R2. And R1 is calculated in the positive x direction, so this will be positive. R2 is calculated in the negative x direction, so therefore it will be a negative R2. Anyway, both are equal to the same value R. So I can just substitute everything over here. This is 1 by 20 centimeters is equal to 1.55 minus 1, that will be 0.55 into 1 by r minus of minus plus 1 by r. So that will be total 2 by r. 1 by 20 is equal to 0.55 into 2 by r. If you cross multiply and arrange, you shall have an answer r as in 20 centimeters. Okay, that will be option C. Question number 20, the last question of the section A. In an electromagnetic wave, if E and B represent electric and magnetic field respectively, then, well, both will be in this always in the same phase. The reason is, if you do E dot B, they will always be 0. They might propagate perpendicular, but since their dot product is coming to be 0, it means their phase difference will also be 0. So therefore, they will always be in the same phase. Next, section B, question number 21. If potential energy of the spring is V on stretching it by 2 centimeters, then its energy when it is stretched by 10 centimeters is 20 plus PV, then value of K is. Well, we know the potential energy equation of a spring is half Kx square, right? That means U is directly proportional to x square, the extension. So I will consider the new thing that is given already. (20 plus P into V divided by original will be V. This is equal to new extension is 100 because x square, original extension is 4 because that is 2 square. So this will give us of 25. These both will cancel out each other. So P shall become 25 minus 20, that will be 5. So here P value shall be 5. Okay. Next question. Question number 22. In a hydrogen atom, electron jumps from fourth excited state to second excited state. Wavelength of the photon is given, value of n is. Well, in the de-excitation and excitation state, the wavelength is given as 1 by lambda is equal to r z square into 1 by n1 square minus 1 by n2 square. Right? So now everything is clear, but let's look at this question again. Fourth excited state, second excited state. Don't make a mistake of taking n value as 2 and 4. This is state, that means ground state will be 0. First orbit will be so in that order. Here the n value will be 3. Here the n value will be 5. Maybe because states will start from 0, 1, 2, 3, whereas the quantum levels will begin from 1, 2, 3. So therefore, n values should be taken like this, and wavelength is given as 9n by 16r. So here if I substitute, this will be 16r by 9n must be equal to r. It is a hydrogen, so z value will be 1 over here. 1 by 9 minus 1 by 25. So this should give us 25 minus 9, that will be 16r divided by 256. Sorry, here I wrote Z, it should be N. Okay, now you can verify. Let's just compare it once again. That will be 16. This will be 180 and 40. Just a minute. Sorry, 225. So 16 shall cancel. So n is equal to 225 by 9. That will give us 25. So n value here will be 25. Next question. Question 23. Fundamental frequency of an open organ pipe is F0. If it is closed at one end, the fundamental frequency becomes n times F0. Okay. So for open pipe, I will take it as F1. F1 value is F0 they said, where this F0 value shall be equal to V by 2L. Whereas for closed open organ pipe, I'll take it as F2, which they gave it as n times F0, but this shall be equal to V by 4L. Okay. Whereas F0 is already V by 2L. So this we can write n V by 2L is equal to V by 4L. So n value shall become 1 by 2. They are asking 2n value. 2n value shall be 1. Next question. Question 24. In this, they are asking us to identify the current in the entire circuit by considering the diodes to be ideal. Ideal diodes mean zero resistance. So this diode will be forward biased and this diode will be reverse biased. Thereby, the overall circuit shall transform into like this: 4, 12, 3, 24. So if you observe R equivalence, 4 and 12 are in parallel combination, that is 4 into 12 by 4 plus 12, 16. That will be 3, and that 3 and 3 will be in series combination, so that will be 6. So total I value will be total E, that is 24, divided by total R, that is 6, and the answer should be 4 amperes. Okay. Last question. In a standard YDSE, two identical slits S1 and S2 are illuminated by light of wavelength lambda. If light wave through slit S1 leads S2 by phase of pi by 3 at point O, then nearest minima to O is at a distance of lambda d by nd. Find the value of n. We need to modify this a little bit. It won't look exactly like this. Okay, let me draw it for you. Because if the point O is right at the midpoint, then we are saying that O is the central maxima. But as per the question, the phase difference at O is pi by 3, which is not resulting in a constructive interference. So let's just consider the point is somewhere here. Okay, Like for example, I'll consider the point O to be somewhere over here. Okay, now there can be a phase difference between each one of them. So from slit S1 and S2, when the light is falling at this point O, there is a phase difference of pi by 3. So what I will do, I will just track the phase difference of pi by 3 line. The common line will be over here, making an angle of pi by 3 with x-axis. Now, pi by 3 is 60 degrees. Usually, constructive conditions will happen for every 2 and pi. That means at 0 degrees, phase difference there will be constructive. Again, there will be at 2 pi of phase difference. Now 60 degree is very closer to this constructive interference for pi by 3 value over here. Okay. So the question now they are saying is there is a nearest minima. That means this one will be having at this particular phase difference of pi by 3 at this point O, the intensity if you calculate, it will be I naught. And the next nearest darkest fringe can be somewhere over here where the intensity can be 0 because brightest fringe intensity will be I naught or 4 I naught. So what I will do, I will consider from this a new position that they have marked till here. Let that make an angle. Since it is very much closer to the first central maxima, thereby I'm considering this thing to be first dark fringe that can make an angle of 180 degree. Again, destructive interference condition, phase difference will be first will be at 180 degrees. Now, the question you observe carefully, the distance of this nearest minima is measured from this point O, which is given as y. Okay, so if I know the path difference between this point O and let me call this as point P, I can get the y value because y value can be related to path difference by using the relation d by d into delta x. Now the point is to get this delta x value. Well, if you know the path difference, how can you get the path difference? You can get the path difference by using phase difference. Now there is a phase difference. The phase of the first one will be pi by 3, the second one is pi. Therefore, the new phase difference between the green line and the blue line, that will be equal to pi minus pi by 3, which will result in 2 pi by 3. So if this is 2 pi by 3, then delta x value will be 2 pi by 3 into lambda by 2 pi. That will become lambda by 3. So if I substitute that over here, y is equal to d by d into lambda by 3. In comparison to this value, n value shall become 3. Okay. So that's all with all the questions of this particular paper. Well, considerably as an analyst, this paper is pretty much straight and easy except for one or two questions. If you could have concentrated on the formula and the application, it is very easy to score 95 percentage of the marks in this paper completely. Okay. Yeah. Thank you. I'll see you again.
Welcome to the session. So my name is Adipt Pandit. Today we will discuss FT-09, the chemistry paper solution. Okay. So in this first question, it is given that the ratio of the radius of the third Bohr's orbit of the lithium dipositive ion. So lithium ion, third Bohr's orbit radii. Okay. And then for the carbon 5 positive, the fourth Bohr's orbit radius, we have to find out the ratio of the radius. So what we will do whenever we have to find out the ratio, we know that the formula R is equals to 0.529 n square upon Z. Okay. So whenever we have to find out the ratio, we will use R directly proportional to n square upon Z. So I can write here just for the lithium. Okay. Then I have to find out for the carbon, the ratio for lithium to carbon. I will write here carbon, lithium, dipositive and carbon 5 positive. Okay. N square upon Z for the lithium. Here N is the principal quantum number, shell number is the third. I will write here actually 3 square. Then Z for the lithium here is equals to the 3. Hydrogen, helium, lithium, it will become 3. This is for the lithium. Then for the carbon, I can write it will be like the Z upon N square. It will become reverse. When we take the ratio, it will just become the reverse. So I can put here for the carbon here, it is the 6. Okay. And the fourth orbit, actually they have given the value of the fourth orbit. So it will become the 4 square. So what will be the value? 3 square into 3 and 6 into 4 square. So this will cut automatically. 3 into 6 and actually it will become 16. So 18 upon 16. So here it will become 9 by 8. So the ratio of the radius of the third orbit of the lithium ion to the fourth orbit of the carbon 5 positive ion will be 9 by 8. So whenever you have to find out the ratio, just remove that value and directly proportional sign will come. And just you will put the values and you can able to find out the answer with help of this. So your answer will be the 9 by 8. Okay. So moving to the next question here. The tendency to show the catenation decreases down the group in group 14 elements. So group 14 elements are the carbon, silicon, germanium, and SN, and PB lead. Down the group, size increases and electronegativity decreases. So first we will actually check both of the statements. So tendency to show the catenation decreases down the group, which is correct. Because carbon shows the actually most catenation. The property of the carbon for showing catenation is the maximum, and while going down the group, size increases, which is also correct. As we go down the group, size increases because the number of shells increases and electronegativity decreases. We have studied that both statements are the correct. So the reason is explaining the assertion. We have to check. So what is the catenation? Actually, catenation is the property where the atom combined with the same atom and form either long chain or a cyclic compound, and it is the stable. So which property is required for the catenation? So I can say the bond strength. So such that the bond strength of that particular two joining atom must be greater so that they can withstand and actually shows the catenation property. So as we go down the group, the bond strength decreases. Why bond strength decreases? The reason is the size. So while going down the group, size increases and bond strength decreases. So that's the reason actually the catenation is a decreases property decreases down the group. Carbon shows the maximum catenation property, and that's the reason carbon can form the millions of compound, and we have categorized a separate branch. So the reason here is one of reason is electronegativity, which decreases down the group, and size, which increases. So as the size increases, we can say actually bond length increases and bond strength decreases. Okay, it is easy to break the bond, so less bond strength is applied, and as the bond length increases, so it will easily break. So actually it can't withhold the catenation property. So here answer will be our C. I mean both statement are true and reason is the correct explanation of the assertion. Okay. So moving to the next question. A larger hot water bath at 360 Kelvin loses the 60 joule of heat energy reversibly to the surrounding, which is at 300 Kelvin, the total entropy change. So what they are asking actually the total entropy change. Okay. So we will actually understand this question. It will better we will understand by this one figure. So what actually question is saying here, a larger hot water bath is there and the temperature is 360 Kelvin here. So we can say this is our system where thermodynamic process is going on, and we can say this is what our surrounding, actually surrounding temperature here is 300 Kelvin, and heat loses. So they are saying actually heat energy loses. So we can say heat transfer from system to surrounding. This 60 joule heat is transferred up to here, it's clear. So as we know, the total entropy is equals to entropy of the system plus entropy of the surrounding. Okay. So I can write here this total entropy is equals to entropy of the system plus entropy of the surrounding. We know that entropy is equals to change in heat upon temperature. So this is the temperature of the system, plus we can say this is the temperature of the surrounding. So in the question, they have given the both value. I think we will put these value and we can able to find. So change in the heat here, actually heat loses. So heat, we can say evolved by the system, heat loses. We will use the negative sign here. Okay. And temperature here is the 360 Kelvin. Plus actually heat absorbed by the system, we can say, because surrounding heat evolved from the system and it reaches to the surrounding. That's the reason here plus 60 will come. Heat transfer to the surrounding, and the surrounding temperature is the 300 Kelvin. Now we can simply find out the value. It will become minus 1 by 6 plus 1 by 5. On solving, we will get just, we will take the common here, it will become just 30. So I think this minus 5 and it will become just plus 6. So it will be the 1 by 30. So on solving, we will get here, we will put 0 and again 0, it will become 100 and 0.33. So delta S, or we can say that the total entropy change here will be the positive 0.033 joule. So the answer here will be the D for this question. So we have to apply this particular formula, that total entropy is equals to entropy of system plus entropy of the surrounding. So I hope this question is clear to you. Fine. So moving forward, we will check the next question here now. Major product form in the following reaction. Okay, so 4 options are given. First, we will check the option here. The reactant here is actually the chlorine present, and we can set para position. Our acid is present. Okay, COOH is present. So the 4 options are possible. You can see here this COOH, and here actually OH is inserted. Then again OH is inserted, and 4 options are given. So we will check one by one what is the possibility here. Okay. So here it is chlorine and here it is COOH. And we can say actually the nitration will take place. Okay. So now listen carefully. As we know that COOH group, all the groups in which the pi bond attached to more electronegative, you can see here pi bond attached to the oxygen. These are the meta directing. Is this clear? So incoming group will add at the meta position, and we can say that the chlorine is the orthopara directing in weak deactivating. So it is the orthopara directing. Is this point is the clear? So with respect to the chlorine, we can say para position already occupied by the COOH, and only at ortho position is the left, and the one is the ortho position for the chlorine will be the meta position for the COOH. So I hope you got my point. Here it is chlorine, okay, and here it is COOH. So this is the meta position for the COOH, while the same is the ortho position for the chlorine. Chlorine is our ortho para directing, okay, and COOH is our the meta directing. So incoming group will add at this particular carbon. So the NO2 will add here. So after the HNO3, H2SO4, after the nitration, we can say that NO2 will add here. This is clear. Now the reduction will take place. I can say SnHCl is there, so reduction will take place. Reduction will take place. So what will happen? This NO2 oxygen will remove and NH2 will be added, as the reduction is what? Addition of hydrogen we can taste. So NH2 will form here. Okay. So the NH2 will form here. Then what will happen after this? After this, we can see this NaNO2. Okay, so this NaNO2 will takes place. NaNO2 and H2SO4 reaction will takes place here. So we can say this is the diazotization reaction. So this is our diazotization reaction where N2 positive and Cl will form at the place where NH2 is present. Okay, and once the diazotization reaction takes place, after that actually this diazotization, benzene diazonium chloride will form. We react with the freshly prepared benzene diazonium chloride with the water. So what will happen at the place of the N2Cl, OH will form here. Okay, so the OH will form here. So what will be our final product? So I will explain it one by again. So HNO3 H2SO4 nitration is going on. So as the chlorine is ortho-para directing, so this actually ortho position for the chlorine, and same is the meta position for the COH, as COH is the meta directing. So we can say at this particular position of the carbon, NH2 group will add here. Okay, sorry, NO2 group will add first, and after that SnHCl in presence of HnHCl, reduction of NO2 will occur. Reduction of NO2 will occur. So NH2 will form. Okay, NH2 will add here, and after that the NH2, what will happen? Diazotization reaction occur. So diazotization reaction occurs. So benzene disonium chloride will form at this particular position, N2 positive Cl negative, and then actually we will react this freshly prepared benzene disonium chloride with water. So at the end we can say this particular position OH will be placed. So what will be the possible option? We can say at first the position the OH is present at the ortho position of COH, which is not possible. Okay, fine. Then we can say like here in B we can say this OH is present, but a Cl is replaced by the OH, which is also not possible. And C also you can say this OH is actually present at ortho position with respect to the COOH, and it is actually reduced to the CH2OH. So the reduction of COH will not possible here. So D will be our answer here. Okay, so what will happen? D will be our answer here. So this will form when actually this benzene disonium chloride, or I can say here this N2Cl, N2 positive Cl negative freshly prepared undergoes with the OH. So our answer here will be the D option for this particular reaction. So I hope this is clear to you. Okay. Filter paper moistened with the ammonical sodium nitroprusside solution turn violet on contact with the drop of alkaline Na2S solution. The violet color is due to the formation of. So what they're asking here, actually the violet color is due to the formation of. So one compound is there, that is the sodium nitroprusside. So it is a very important compound which is also present in the NCERT. So what will be the formula of the actually sodium nitroprusside is the FeCN5 here, NO, Na2, or we can write here -2 or Na2, both will be the okay, fine. So as the sodium nitroprusside is there, so we will write here Na2. So this is the formula of the sodium nitroprusside. You must know the formula of sodium nitroprusside. As this compound even mentioned in NCERT, so at least NCERT compounds, it will be better if you can remember. So what they're saying here, actually this Na2S, sodium sulfide solution. Okay, so what will happen? This it will reflect to Na positive and is sulfide. So sulfide and actually just will add here. Okay, and it will just react here. So what will happens? A violet color complex will form, and we have to actually tell what is the structure or what is the formula of this particular violet color complex. So I can say here Fe, then this CN5 and NOS. So this NOS actually will form here, and overall -4 charge will come at the bracket, or we can say Na4 as a counter ion. Either we can write here Na4, it will be the same, or we can write here as a -4. So both are the same cases. Okay, so a violet color complex will form here. So this is the reaction actually here. So the option here actually, the correct option for this question is the D here. So I hope this is clear to you, that the ammonical silver sodium nitroprusside solution turned violet on contact. Okay, so this is the sodium nitroprusside solution where when actually it's in contact with the sulfide, it will become just a violet color. So we have to actually check the particular formula of this color complex, and this reaction is mentioned in the NCERT. This complete reaction is mentioned in the NCERT, so you can check that. It is a very important one. Okay, so in this question, actually, what they are saying that the pKa of the monobasic organic acid is the 4.2. So pKa given here is the 4.2. Okay, and the pH is we have to find out. So pH at which 80% of acid is ionized. The 80% of the acid will be in the ionized form. So at what pH 80% of the acid will be the ionized? So I can say this is the Ha, one of the acid is there. So it will just actually give the H positive ion and the conjugate will form here. Okay, so what they're saying is that 80% of the ionized form is present. At what pH the 80% of ionized actually form will be present? So we have to find out that particular pH. At that pH 80% ionized form is there, so we can say that 20% of the unionized form is still left. Okay, so we know the formula, one formula, that pH is equals to the pKa plus, I can say, log ionized form upon unionized form. So I hope we know all this formula. In pKa is given here. So what I will do, I will just put the value here, 4.2 plus log. Okay. So ionized form actually is here given is the 80%. So I can write here the 8 I will write here for the ionized form, and 20% anion is still left. So I can write here actually the unionized form, which is the 20%. So for the simplification, I just written here 8 by 2 on the numerator. 8 is the ionized form, and here 2 is the unionized form, and we have to find out the pH at which 80% of the acid will be ionized. So what will be the value here? 4.2 plus it is, as it is in the multiple, so we can write here log 4. So what will be the value of the log 4? You must know the values of the log base 10. So log 4 value, we can take here 0.6. Value of the log 4 we can take here 0.6. So it will become 4.2 plus we can write here 0.6. So it will become 4.8. So for this question, the sixth question, our answer here, correct answer will be A. Okay, so I hope this is clear to you. So what just we have to put the value of the ionized and unionized form, and that is the important only part. And our final answer will be 4.8. Okay, moving to the next question here. So among the following, the most stable conformation of the meso 2,3-dibromobutane. So what they are asking, just they are asking here actually the most stable conformation of the 2,3-dibromobutane. So in conformers, we know when the bulky groups are present apart, so less repulsion is there. As the less repulsion is there, so the more stable will be the conformer. As in this case, hydrogen bonding is not possible. So what we can see, that eclipse and the staggered form, as we know that eclipse form are the less stable, while staggered form are actually the more stable, because bulky groups are present actually at the farther distance, or we can say that angle between them is the more, so the repulsion is the less, so they are the more stable. So total 4 options, all the 4 options we will check, and then we will find which one will be the most stable conformation. So we can see in this A conformation, this bromine present just at adjacent position. So bulky big groups are present at adjacent position, and methyl is present at adjacent position itself. Okay, so the repulsion will be more, so this will be the least stable. So A is the conformer, but actually it is the least stable because the bulky group present nearby, so it will create the hindrance. Then we can see actually this B and C option, C, D, total 4 options are there. So this B option is actually not the conformer, and even the C1 is also not the conformer. And we can check the both of the group present here are just presented adjacent position. The bulky group presented adjacent position, which creates the repulsion. So it is the less stable. Then we can check for the D option. In D option, we can check both the bromine just present at the 180 angle. Okay. More is the distance between the bulky group, less is the repulsion, more stable is the conformer. And we can say even the 2 methyl group present, the 2 methyl groups present are also present at just opposite point, or at the 180-degree angle. Okay, so here we can say actually the bulky group present at the distance between the bulky group is the more, or we can say even that angle, the angle is the more, so less is the repulsion. As less is the repulsion here, so more will be the stability. So more will be the stability here. So that's the reason the correct answer here will be for this question is the D. So for the seventh one, the correct answer here will be the D. Okay. So moving to the next question here, which of the following compound is the diamagnetic? What they are asking is the diamagnetic. I mean, no paired electron. Okay. Yeah. So when actually no unpaired electron, all paired electrons are present, or we can say the magnetic moment is equals to 0. So we have to check that in the diamagnetic. So we will check one by one here. The oxidation number in the A option here, we can say oxidation number is Mn plus 3. So what will be here the configuration? It will be just, I can say 3d3. For Mn it is 3d5 4s1. So we will remove the 3 electrons. For Mn plus 3 it is 3d3. So I hope this is clear to you. Now they are asking the diamagnetic. Okay, fine. So like no unpaired or all the paired electrons are present. So when 3d3 configuration is there, actually it is always with the unpaired electron irrespective to the strength of the ligand. Effect of ligand will not applicable from D1 to D3 and our from D8 to D10 configuration. Either they are the weak ligand or either they are the strong ligand, and paired electrons are the present, so they are the paramagnetic. So I hope the first option is clear to you. CrH2O6 plus 3. So for the chromium configuration is the 3d54s1. And we will remove here actually for Cr plus 3. Again it will become, I think, yeah, it is 3d4, sorry. Yeah, 3d54s2 for Mn. The atomic number is the 25. So it is 4s2. 3d5 for the Mn, and for the chromium it is 4s1, so it will become the 3d4. So we have to check the diamagnetic one. Okay, so this will be the configuration because we want only the 2 orbitals, so still actually the number of unpaired electrons are the present here. When it's come to the chromium plus 3, so for the chromium plus 3 here, we can see the 3d3 configuration is there. So as I have told that from d1 to d3 configuration, actually either the ligand is strong or the weak, there is a no effect. So this particular compound is also the paramagnetic, I mean unpaired electrons are the present. When it's come to the Fe for negative, so this is the Fe di plus. So what will be the configuration here, valence configuration? It will be the 3d6. Okay, so the 3d6 will be there, and as we know fluorine is the weak field ligand, so it is the weak field ligand, so no pairing will occur. As no pairing will occur, so number of unpaired electron remain, it will be the highest in this particular case out of all the 4. So both A, B and D, all the 3 are the paramagnetic and presence of unpaired electron is present. So the option will goes with the C. So for the cobalt, atomic number is the 27, that is the 3d7 and 4s2. For cobalt plus 3, it will become 3d6, and NH3 with the plus 3, cobalt plus 3 act as a strong field ligand. So what will happen in this particular case? In this particular case, we can see here that the pairing occur. So this one is the diamagnetic. So C compound is the diamagnetic here, in which no unpaired electron is the present. Beside in A, B and C, the unpaired electrons are the present. So for the 8th question, our answer will be the C. Okay. So in the next question here, we will check what they're asking is the what will be the correct order of the absorption of wavelength of light in the visible region for the complex. Okay. So they're asking the order of the wavelength of the light. Fine. two concept actually we will discuss here, which is important to solve such type of the question. First, we know that octahedral energy. So this is also the type of the energy which is more for the strong field ligand. For a strong field ligand, this delta O energy is the more. And as we know that energy is inversely proportional to lambda, E equals to hc upon lambda. By that formula also we can conclude E is inversely proportional to the lambda. So one with the more this energy, I can say actually the wavelength shows that will be the less. Now in the visible region Vibgyor, as we move from left to right, so here the wavelength is the maximum and here the wavelength is the minimum. So in this question they have not asked even the color, but actually for such type of the questions actually we can use this. Okay, so what we have to check here, we have to just check one is with the strong field ligand having the greater energy and the wavelength will be the minimum. So strong field ligand is having the delta O maximum, so that's the reason the wavelength will be minimum. So we can see central metal ion is the same, and we can see the charge present on the central metal ion is also the same. These two factors are the same, only ligand difference is there. So cyanide is the, if we can check the strength, cyanide is the strongest ligand, then we can say here NH3, and after that we can say the H2O. This is the strength of the ligand. Okay, so the strength of the ligand, the delta O will be the order also be the same. So the order of absorption of wavelength just become reverse. So the correct answer for this particular question will be the C. So the coordination compound having the H2O as a ligand, okay, because it is a weak field ligand. So delta O is the less. So the absorption of the wavelength will be the highest. Then for the NH3 and at last for the CN. Simple concept, you know the strength of the ligand, more the strength of the ligand, more is the energy, and energy is inversely proportional to the wavelength. I hope this is clear to you. Okay. So how many of the following elements form the amphoteric oxide? Amphoteric oxides are those oxides actually which shows both acidic and the basic nature. Which shows both acidic and the basic nature are the amphoteric oxide. So the compound given here is the silicon, then phosphorus, then actually nitrogen, boron, then ascentine, then Pb lead, then oxygen. Okay. So phosphorus is actually P2O5. It forms the acidic oxide. Okay. Phosphorus forms the acidic oxide. Same we can say for the silicon. Silicon also forms the acidic oxide. In general, we can say especially first and second group element form the basic oxide, while the extreme left side form the acidic oxide. In the periodic table, right side, I mean those present on the right side, and that halogen actually that form the acidic oxide, while on the extreme left first group and second group compound forms the basic oxide. So Si2O is also forms the acidic oxide. Nitrogen forms a lot of oxide like N2O5, then we can see this N2O3, then NO, then N2O. These two are the neutral oxides. Okay, as the oxidation number of the atom increases, acidity of the oxide increases. So these all are the acidic oxide. They all form the acidic oxide. Only Sn and Pb element form the amphoteric oxide here. So I hope this is clear to you. So amphoteric oxide in all these given options, Sn and Pb will form. So for this question here, the correct answer here will be the D. Okay. So moving to the next question now. Okay. Which of the following aqueous solution has the maximum boiling point? So this question is from the chapter solution. So they are asking the maximum boiling point. So we know that elevation in boiling point is equals to Kb into molality, and I will add here Ventos factor as Kb is the constant. So delta Tb is directly proportional to I into molality or concentration. Up to here it's clear. So the Tb we know that the elevation in boiling point. So the elevation, the boiling point of the solution they are asking, which is directly proportional to the product of the Ventos factor, and M molality here is the concentration. So there is no discussion about the concentration. We can even consider the concentration here. No discussions of the same. So simple boiling point solution directly proportional to the Ventos factor. So what will be the Ventos factor here? For here it will become just 2 Na positive plus SO4. So I can 3 say 3 here, and again here it will be 3. Here this Al2SO4 whole thrice electrolyte just dissociate to gives 2Al3 positive plus 3SO4 minus 2. So 2 plus 3, total 5 ions are there. So actually the value of I is the highest for the I value is highest here. And this C12H22O11, this is the table sugar. Sucrose is the non-electrolyte. So I value is equals to the 1. So higher the I value, higher the Ventos factor, more will be the boiling point. Okay. So that's the reason here. The maximum boiling point is for the C1 aluminium sulfate. If they will ask the minimum, it will reverse, answer goes to the T. Okay. And if they will ask for the freezing point, so depression in freezing point is there. What will happen? Depression in freezing point is there. So it will just become the reverse. Okay. More the value of this, so lesser will become the value of the freezing point if they will ask for the freezing point. But here boiling point is there and maximum boiling point, as there is no discussion about the concentration, so we will directly check by the I1 is having the higher value of I or the Ventos factor. So simply what we can say, the boiling point for that solution will be the maximum. So the correct answer here will be C. Okay. So unit for the equilibrium constant they are asking here. So we all know that equilibrium constant is equals to the concentration of the product upon concentration of the reactant raised to the power stoichiometry. We can say that 2B is the solid here, and for the solid always we will take the concentration. We don't consider the concentration because for the solid and the liquid it's a unity. So always we will take for the gaseous or the ions. Okay. So what we will write here, Kc is equals to concentration of C and concentration of A in power 1. So actually both will cancel and it will become actually the unit less. So in this particular case, it will become the none of these. So we can say here also that the unit of Kc also depend upon that the stoichiometry of the reactant or product. According to that, it changes the unit of the Kc. In this question, this 2B is present in the solid form, so we will not consider. A and C is having the single stoichiometry, so both will cancel out each other. So for this question, none of these, and then the answer here will be the D. Okay. So moving forward, and we will check the next question here. Fine. So compound is given here, and ZnHgHCl, and after that the HCl. So it undergoes the two reactions, and what will be the major product? They are asking for the major product. So here it is ZnHgHCl. So we can say this is the Clemenson's reduction. Okay. So this is again the name reaction, and this name reaction is from the NCERT, which is very, very important. So ZnHgHCl is there. It undergoes the reduction. So reduction occur of the carbonyl compound. Okay. So what will be the product form? We will check one by one. So this is what our even substrate here. Then what will happen? This ZnHg zinc amalgam in presence of acidic medium, it will just react. So what will happen? The reduction occur, and this O just will remove. This O will remove. Okay, and it will form the product like this. Fine. Then in the second step, we can see here HCl is there. So this is our, we can say, the hydrohalogenation. It is an electrophilic addition reaction and product form according to the Markovnikov rule. The product form according to the Markovnikov rule. Okay. So what Markovnikov says in simple terms, I can say the negative part of the reagent or adding molecule add to sp2 carbon with less hydrogen. What Markovnikov says, negative part of the adding molecule, okay, or I can say here reagent, that HCl will add to the sp2 carbon with less hydrogen. So you can see actually only double bond present here. So over these two carbon, this HCl will add as per the Markovnikov rule. So what we will check here on this particular carbon, wait a minute, we can say already three bonds they are forming. So in this carbon, one hydrogen is present. On this carbon, already this methyl group is present. So no hydrogen is present here. Okay, so we can say this negative part will go and add over here as per the Markovnikov rule. So negative part will just go and add over here as per the Markovnikov rule. So what our final product will form here? So in this case, our final product will form here. Yeah, so this is our methyl and this is our Cl. So this is our final product, or this is our the major product will form at the end. So the methyl and here chlorine is attached to the same carbon. We can see in the option which option is given here. So chlorine and methyl. So the correct answer, the correct option for this particular question is the B here. So in this question, this ZnHgHCl is their Clemson's reduction. So actually, carbonyl compound undergoes the reduction to gives the alkane, and the name reactions are very important here. And after that formation of alkene, we can see in this 6-member ring a double bond is present, alkene is present, and this HCl will add as per the Markovnikov rule. So the negative part will go on the sp2 carbon, which is having the less hydrogen. So final product will form here, and B is the correct option here. Okay. So moving forward here, and which of the following statement is incorrect? So first of all, we have to read question very carefully. They are asking which of the following statement is incorrect or the wrong. Only oxidizing acids react with the copper, which is correct. So in the electrochemistry, like we have seen that actually the elements with the SRP -1 with the negative SRP replace the hydrogen from the acid. The copper is having the actually the positive SRP. So that's the reason if we can see the question here like Cu plus H2SO4, no reaction will be there, but Zn plus H2SO4, this one is having the negative SRP, standard reduction potential. It will replace the hydrogen, so it will become just ZnSO4. So the first option is the correct. The high energy to transform. Okay, so the high energy to transform here, Cu to Cu dye positive, is balanced by the hydration enthalpy. So we will check other options also, like both the observed as well as the calculated E0 value from M dye positive to M. I mean, we can say the reduction potential value for copper are highest compared to other 3D element. So which is the correct? C and D option we can say is also the correct here. B option, what B option is saying, the high energy to transform the copper solid to the Cu dye positive gas is balanced by the hydration enthalpy. Copper has high enthalpy of atomization and low enthalpy of the hydration. Thus, high energy to transform the copper solid into aqueous is not balanced by the hydration enthalpy. So actually, this statement is incorrect here. It is not balanced by the hydration enthalpy. First of all, here it is given is the gas. So it will not balance. And second thing, the copper is having the high enthalpy of the atomization also. Low enthalpy of the hydration, so that's the reason it will not balance here. Okay, both observed as well as the calculated the reduction potential of Cu are highest compared to other elements. So this is also correct. Among all the 3D elements, only zinc has more third ionization value. So for the zinc, simply we can check here and we can find out the value of ionization potential. So I can say this is what our first ionization potential, this is what our second ionization potential, and what they are saying is third ionization potential value is higher than third ionization potential of the copper. We will check that. So what is the configuration here? It is 3ds4s2 for the that is for the nickel. So for the copper and after that the zinc, so it is the 3d10 and 4s2. Then one electron just we will remove, so it will become 3d10 and 4s1. Okay, then it will become here 3d10. So it will achieve, actually we can say here the subshell here is actually fulfilled, so it is the stable. So when we remove the electron from the stable, or we can say the fulfilled subshell, the more energy is required, more ionization enthalpy is required. So what they are saying is only zinc has the more third ionization enthalpy than the third ionization enthalpy of the copper. For copper we can check, it is 3d10 4s1. If we will remove the one electron, what will be the configuration here? So what configuration will be here? We can check, it will become the 3d10. Okay. Then we will just remove one more electron, I mean second ionization enthalpy. It will become just Cu positive and it will become 3d9. And then third ionization enthalpy is the 3d8, and we can say this is the Cu positive. So in the last actually statement, it is given among all 3D series, only zinc has more third ionization enthalpy than the copper. So it is correct, because actually third ionization enthalpy, we can see we have to remove the electron from the stable fulfilled configuration of the zinc. While in the copper, second ionization enthalpy has the higher value, because just after giving one electron, it has achieved the fulfilled configuration, which is the stable fulfilled configuration. But in the option, they are asking for the third ionization enthalpy value. So for zinc, it is the greater compared to the copper. So all statements are the correct. Only the B option is the incorrect. So here answer will be, correct answer will be the B, which is the statement is the incorrect and the wrong. Okay. In next question, they are asking the order of reactivity of the compound. So order of reactivity of the compound towards substitution with given electrophile. I mean electrophilic substitution reaction they are asking. Okay. Now the electrophile substituted only when the compound have the more, we can say, electron density. The one compound with have the more electron density, greater is the electron density, easily the electrophilic substitution reaction will be there. So we have to check the electron density here. Okay. So first one is what? First one is the negative charge species, we can say O negative. So this one is having the highest electron density. It will show the electron donating group or the electron donating effect by the both mesomeric and inductive. Okay, so it will show the plus M and plus I. While second and third also shows the electron donating, they are the electron donating group and the electron donating effect. But always remember here O, then C double bond O and this group. So in the second compound, we can see this group is present. And in the third compound, we can say here NH. And then C double bond O, this group is present. Okay, I'm writing here pH and I'm writing here again pH, and the lone pair is present. Now which one will actually increases the more electron density here, or which will be the better electron donating group? So oxygen is the more electronegative. We can say the negative or lone pair on more electronegative will be more stable. As the lone pair will become more stable here, so it will become difficult to donate. It will not donate easily, or actually the delocalization will occur difficultly around the benzene ring compared to the third structure. In third structure, we can see nitrogen. Nitrogen is the less electronegative compared to the oxygen. So the delocalization of the electron occur easily compared to the second one along the ring, because negative one more in more stable. When it's become stable, it will not actually easily donate, or it will not easily undergoes the delocalization. So what will be the correct order? First, I can say, because already the negative charge is there, excess of the negative charge is there. Then out of second and third, I can say the third one. Out of second and third, I can say the third one, because the nitrogen is less electronegative. So the lone pair is present here also and here also. Then I can say the second one. In all of the three, actually, the mesomeric effect is going on. That is the plus M effect. And at the last, you can see only alkyl group is present. So alkyl group is present here, the isopropyl group, which shows the electron donating only by the plus I effect. Okay. And no mesomeric effect will work here. So that's the reason the order will be first, third, second, and after that at the end, fourth. This will be the order towards the substitution by the electrophile. So I hope this is clear to you. Fine. So the answer for this particular question here will be D is the correct option. D will be our correct option. So I hope the point is clear to you. So moving to the next question here now. Okay, which of the following statement is not correct from point of view of molecular orbital theory? Again, they are asking the not correct. I mean, which of the following statement is the wrong here? Okay, so the bond strength, starting that the Be2 is not a stable molecule, which is correct. So what are the conditions when the molecule will be the stable? When the bond order is greater than 0. And how you can find out the bond order? Number of electron in bonding orbital minus anti-bonding divided by 2. As we know, though, two molecular orbitals are there. Number of bonding electrons in bonding minus number of electrons in anti-bonding divided by 2. By this, we can find out the bond order. Greater the bond order, greater will be the stability of the molecule. Okay. So if the bond order is greater than 0, then the Be2 actually or any molecule will be the stable. But in the case of the Be2, we can find bond order is the 0. So it is not a stable molecule, which is correct. He2 is not a stable, but helium and 2 positive is expected to exist. We will check He2. So we can say number of electrons here will be 4. So I can say sigma 1s and here sigma star 1s. So 2 and 2, we can say 2 electrons in the bonding, 2 in the anti-bonding. So I can say by this formula bonding order will be the 0. In case of He2 die positive, 1 electron removed from the anti-bonding. So it will become the sigma star 1s1 and here sigma star 1s2. This is the molecular configuration. So I can find the bond order here, that is 2 minus 1 by 2, it will become half. So I can say He2 is not stable, but helium He2 positive expected to exist. This is also correct. Bond strength of nitrogen is maximum among the homonuclear diatomic molecule. Homonuclear, when the two similar atoms are bonded to form a molecule, is the homonuclear and diatomic. So bond strength is the maximum, which is correct. So for the last one, actually, the order of energy for the molecular orbital of F2 is not the same. This order is not the correct order. The correct order actually is the sigma 1, sigma 2 pz will come before and after that the pi 2 pz and y will come. So out of the 4 given options, the wrong one is the D. So the correct answer here will be for the 16 is the D, and the rest 3 are the correct, and D1 is the wrong. So it is the correct for the 16th question. Fine. So for the 17th question, the rate constant of first order reaction is 3 into 10 to the power minus 6 per second. Initial concentration 0.1, initial rate of the reaction. We know that rate of the reaction is equals to the rate constant, and suppose A is any one of the our reactant, and as first order reaction is 1. We have to find out the initial rate of the reaction. So R is equals to 3 into 10 to the power minus 6. And I will write here the concentration is 0.1 as order and power is the 1. So simply 3 into 10 to the power minus 7. Very simple question, direct formula based. You have to put the values here. Okay, you will just put the value and you can find out the answer very easily. Fine. So the correct option here, A, 17th is A. Moving to the next one, reaction of KMNO4 and HCl results in. Now we will clear one thing here. This KMNO4 is in the +7 oxidation state, which is the highest oxidation state. It is the highest oxidation state of the manganese, so it will always act as an oxidizing agent. I mean, it will undergo the reduction. It further can't lose the electrons. It is the oxidizing agent. And we can see this HCl is there. So HCl is present in the -1, or I can say the lowest state. So when any element is present in the lowest oxidation state, okay, it will act as a reducing agent. I mean, it will gain more electrons. And when it is present in the highest oxidation state, it will act as an oxidizing agent. So here HCl present in the -1. Okay, so what will happen? It will undergoes the oxidation. I mean, oxidation number of the chlorine will change. So what is the possibility here? We will check the possibility here. So it acts as an oxidizing agent, oxidized other, and actually they will self undergoes the reduction. Fine. So the reduction of Mn will occur. So I can say the A and C option is already eliminated. Okay, and production of the Cl2 will occur. So what will happen here? This HCl, this 2 HCl will undergo and forms the Cl2. So here it is -1, and here actually chlorine will become 0. The oxidation state of the chlorine will become 0, and it will under from -1 to 0. So production of the chlorine gas will occur. So for this question, the correct option here is the D. I hope this is clear to you. So this KMnO4 is in the highest oxidation state, act as an oxidizing agent. It will oxidize HCl. HCl is actually act as a reducing agent, and it will just reduce and itself get the oxidized. So the correct answer here will be the D. So moving to the next question, in the following reaction sequence, structure P and Q respectively, we have to find out the P, and then we have to find out this particular Q, and total 4 options are there. So we will check one by one, like which particular product will form here. Okay, fine. So on the next page, I will just draw the structure, and then I think we can start. So it will be better. Okay, so this is what, let me draw the structure here. Fine. So this is a 6-member ring, which is just drawn a little bit. Fine. Now it's clear. So it is actually a 6-member ring here. So better just wait a minute. I will draw here again, so it will become more better. Yes, now it's fine, I think. And we will add here oxygen O. It's perfect, fine. So drawing the structure, and then we will start. Here it is CH2Br present here, and then HBr is there, and after that the ether will, HBr is there, then we will heat, and after that Na and ether, it will react, and we have to find out the final product. Fine. Here it is CH2Br. Fine. So the first one, if we can see that which particular reaction is this. So here it is the ether, the cyclic ether is there. Okay. So when ether actually react with the HX, so it will form the alcohol. Okay. It will form the alcohol plus alkyl halide. And this is the cyclic ether. So what will happen here? This lone pair is present over here, and this lone pair actually will just attack here. So what going to happen here? Simple. The another structure I'm drawing, just the rough structure. I hope this will become clear to you. So this O, and here actually H will come and the positive. Yes. So it will form like somewhat like this. Okay, then what will happen? Now the ring opening will take place. This ring will just open. So for our convenience, I'm writing the carbon number. This is first, this is second, this is third. Okay, so the ring will open, and actually what will happen here? We can see that the OH will just remain intact, OL will remain intact here, and the ring formation, this ring will open. So what will be our next structure here? So after opening of the ring, it will goes under like this OH. Fine. And total 3 carbon, 1, 2, and 3. Fine. And it will be like, sorry, this CH2, and here it is Br. So H positive part we have already actually just attacked here, and OH is formed, and the remaining Br part is there. Okay, so this Br part will just come and attach here. So actually this positive part will come here, and the Br part, remaining Br part of the HBr will come and attack here. So this particular structure will form, and we can see here the product form like this is the Br, and again this is our CH2Br. Now please understand and try to understand that which reaction can be possible. There is Na and ether, and we can see actually these are the two our alkyl halide. So we know Roots reaction that Rx plus Na, it will undergoes and it will give RR, like two molecule of Rx. We all know that Rx plus Na undergoes, it will give just RR and NaX. So this is the intramolecular. It is going in. Okay, this is the intramolecular. It is clearly written the intramolecular product will form. So what will happen next? Can you guess? So this Br actually, and we know that the Roots reaction is the free radical substitution reaction. So this Br just will shift here, remove, and this Br will also remove here. And total 4 carbon ring will form. We can just write here 1 and then 2, total 3 carbon. Yeah, this is first, second, and third. So total 4 carbon ring will form here. This is one, and the lower one carbon, these both will combine and finally they will form a 4 carbon ring. So our final product form here will be, yes, and here it is OH. So the aromatic compound, okay, this ring is the aromatic and another one is the, so this is our Q product is the formed here, and our P product form is the, yeah, this one is our the P product. So in the question what they have asked, I will explain you again. First of all, this is the cyclic ether and it will react with HBr, then the heating occur. The P will form, we have to find out both P and Q. In the following reaction, structure P and Q respectively. First, we have to find out which one is P and which one will be Q. So intramolecular product will form. So first of all, this ether react with HBr to give the alcohol as we have discussed. So I will explain you again here. Okay, so this H will just come attack here over here and we can see this OH will form. Now ring opening takes place. So once the ring opening will takes place, we can see total 3 carbon is present and positive charges here. So that the bromine of this H positive come and attack here, we can see this product form here. You can see this product form is the P product. Okay, where actually the both bromine are present. Now this P product undergoes reaction with sodium and ether. It is a type of Roots reaction, intramolecular Roots reaction. So the final actually our ring form is the Q1. So the correct answer here and the correct structure will be, we can see it will be the D1. So D is our correct answer. A very good question here. So it includes actually the both. First of all, the cyclic ring is there, that ring will open, and after that, the intramolecular reaction occur, and again ring will form. So the very good question here. So the answer here will be the D. Okay, in the nitration experiment, 10 gram of benzene give 13.2 gram of the nitrobenzene. The percentage yield for the nitration of benzene. So we have to find out the percentage yield. So we know that C6H6 plus, I can write here, suppose this HNO3, it will be the better, H2SO4, and it will become C6H5NO2 plus here I can write here H2O suppose. So what they're saying that the 10 gram of benzene is formed, and we know that the molecular formula for the benzene is the 78. So this will be the number of moles. So on solving, almost I can say what I will get here. So on the solving, and this C6H5NO2, they are saying that 10 gram of benzene gives the 13.2 gram of the nitrobenzene. Okay, so by these data, we have to find out the percent yield. What we have to find out? We have to find out the percent yield. So what we will do in the next here, this will form almost 0.128. Okay, this is the number of moles. As we will check stoichiometry, by 1 mole of the benzene, 1 mole of nitrobenzene is forming. So the number of moles formed should be 0.128. This one is what actually we have calculated. The calculated value. Okay, and what is given in the question. So in the question we can say what will be the given. So what is the molar mass of the nitrobenzene here? We can easily find out. So this will be the 77 plus nitrogen 14 plus it will become 32. So I can say 77 plus here it will be okay 46. So it will become almost 1, 2, 3. Yes, so 1, 2, 3 will be molar mass of the nitrobenzene. So there I have given the 13.2 gram is obtained. So we will check number of moles here is 13.2 divided by 123. On solving, we will get almost a value of the 0.107 moles. Okay. Now we have received the two values. One is 0.128 and one is 0.107 moles. As we know, now we will apply the formula of percent yield. So we know that the percent yield formula is actually, we can say the mass or the moles formed. One is what the mass or the moles formed, or the total mass obtained here. So the total mass obtained here will be, so this total mass in the denominator, we will just put the value of the stoichiometry. By the stoichiometry, this value, calculated value, okay, we will put here the calculated value in the denominator, and the mass or the moles form which is given in the question. This one value is given in question, or we will just calculate by the, okay, so we will put here this value. So what will be the percent yield here? The so percent yield just become here 0.107 upon 0.128 into 100. So on solving, what we will get here? So finally on the solving, we will get the value. It will become just almost 108, and sorry, this is the 10.7 and it will be the 0.128. On solving, we will get almost the 83.7%. Okay, so only the calculation is required. So the correct answer for this question here will be the A. So the value we will get here is the 83.7%. Okay, fine. So I will tell you just quickly this particular, with help of this mass, the 10 gram of the benzene actually we have taken. So we will find out number of moles here is this. So two values we will get, and by that we will find out the percent yield. So percent yield actually the mass, or we can say the moles form upon total mass obtained. So we have obtained this particular value 0.128. After the calculating, we will put this in the denominator, and whatever actually it's giving, they gave 13.2 gram. This value we will keep in the numerator to find out the percent yield. On final calculation, we will get the value 83.7. So the correct answer here will be the A, and 83.7. Fine. How many moles of RMGX can be consumed by the 1 mole of the compound? So this Grignard reagent, how many moles of the Grignard reagent is required? Okay, so as Grignard reagent is the very reactive compound, we know. So what will happen here? It will react with the all possible functional group. So we know actually with aldehyde, actually 1 mole of it's required. It reacts with the aldehyde and give the alcohol. It reacts with the ester also, and in ester the 2 mole of Grignard reagent is required. 2 mole of the Grignard reagent is required here. Okay, and here 1 mole, again here 1, and again here 1 mole. So we will add all the value and we will put in the 1, 2, 3, and 2 moles are required for the ester, so it will give the 3-degree alcohol. So total 5 moles is the required. So here correct answer for 21st is the 5 moles. Okay, how many reactions are correctly matched with the major product? Okay, so they're asking actually the product form here is correct or not, and total here 7 options are there. So we will check it one by one here, that what will be the possible products form. Fine. So we can see here is OH and PH and 2 positive. This is the coupling reaction. So we can see this is the correct. It is a, we can say the coupling reaction. So the product form is the correct. NH2 and CH3Cl AlCl3. So this is the Friedel-Crafts reaction. You can see this is what the Friedel-Crafts reaction. So Friedel-Crafts reaction, aniline will not give the Friedel-Crafts reaction. Okay, why? The reason being that actually because it will form the acid base salt and the positive charge will acquire here, which is the strongly deactivating. It acts as a strong deactivating group, so further product will not form. So aniline will not gives the Friedel-Crafts reaction because it is a base, and that is the Lewis acid. So acid base reaction will form occur and the salt will form, and it will act as a strongly deactivating group. So this particular is not the correct. So how many reactions are correctly matched, they are asking. Now we can see here again HNO3 H2SO4. This is our the nitration reaction. So we can see actually both are, this is the ortho para directing at para position CH3 is present, so at ortho position NO2 will form. So we can say first and third is the correct product form here. This is aldol reaction. Fourth one we can say aldol reaction. Alpha hydrogen containing carbonyl compound react with the bases to give the alpha beta unsaturated aldehyde. So this is what our aldol product, which is correct. Coming to the fifth one. So fifth one we can see that pH phenyl ring COO. This is what CH2. Then here it is COOH. Then on heating, the pH and COO CH3 will form. Fine. So whenever we will heat, so actually the CO2 will remove here. So what will happen? The decarboxylation will occur. The decarboxylation will occur here. So the CO2 will remove here and the hydrogen. Okay. So the final product form here is the acetone. So this is also the correct. Then CH3 and actually the KMnO4 is oxidizing agent. It will forms the benzoic acid, and then again NaOH and CaO. This is the our mixture. Actually it undergoes the decarboxylation and the removal of CO2 and benzene will form. So this is also correct. First, this toluene undergoes the oxidation in presence of KMnO4 to form benzoic acid. Then NaOH and CaO. This benzoic acid undergoes the decarboxylation in presence of NaOH and CaO, calcium oxide, and decarboxylation. CO2 will remove and benzene will form. The seventh reaction we know that HCl plus NaNO2. So first it will react to form the benzene diazonium chloride N2Cl, N2 positive, Cl negative. Then this CuCN, so cyanobenzene will form. This is another Sandmius reaction. This cyanobenzene will form after that for the cyanide compound, nitrile compound. Whenever the acidic hydrolysis will be there, I can say H2O or H positive. Whenever acidic hydrolysis of a cyano compound or nitrile will be there, so the benzoic acid will form. So all reaction present here actually gives the correct product except second one. So we will count. This is first, this is second, and I can say here third, fourth, fifth, and after that I can say here this is the sixth. So total the reactions correctly match with their major product is the 6. So for the 22nd here, the correct answer is the 6. Moving forward here, total number of product in above reaction. So this is alkane and Cl2 in presence of the HMU IV in sunlight. So it will undergo the free radical substitution reaction. Free radical reaction to gives the haloalkane. Now, one questions come actually here with many students are how to find that the product form is identical or same. What we have to do at each and every carbon, we have to substitute chlorine and check the IUPAC name. Fine. They are asking total number of product. So I will draw here first. Then we will check. So we will start from the right side. Okay, and one by one we will add the chlorine here. I'm just okay. So suppose if I will add here chlorine 1, then I will add here chlorine. This will be the second. Then I will add here chlorine. This will be third. Then I will add here chlorine. This will be fourth. And I will add here chlorine. This will be fifth. So total 5 products are possible only or not. We will check that one by one. Okay, fine. So at this carbon, second thing we will check, are they identical or are they same? So we can check actually the IUPAC naming also, are they identical or are they same? Okay. So if I will give the number here first, then second, then third, then fourth, and then fifth. So I can say this first and third is identical. Tell me. Okay. So I can even start like this: first, second, then third, fourth. I can start like this: first, second, third, fourth. Can you see at second position the methyl group is there, and at first position the chlorine is there? So I can say this first and third is the identical, so it is already the same. So how many products are left? 4 products. Fine, 4 possible products. Now we can see, is it possible that the optically active chiral carbon is also there? You can check, is it possible or not? You have to check that. Okay, fine. So these are, I can say, identical. Okay, fine. Now we will check here. And now in this particular case, in the fourth one, you can say this one is the methyl group present. On the right hand side, one more actually group is present and hydrogen is present. So on the fourth structure, the chlorine added to the part carbon, is this carbon is optically active, or I can say the chiral carbon is there or not? It is there. The chiral carbon is present. Okay, that's fine. Okay, then we can check at another possible, in which of the following structure is it possible that the chiral carbon, more chiral carbon is there or not? Is it possible again? So if the chiral carbon is there, then the optical isomer will form. Chiral carbon is there, no symmetry is there, so it will show optical isomer. I mean the two possible isomers are there, so we can say the two product here. Is this clear? Okay. Then we will check for the which another one where the optical active, is it the optically active or not? We'll check that. Okay, so one more is the remaining here. So actually, yes, so we will check. Yes, so I can see here this first one, or this any one of them here. This carbon, the second carbon, is the optically active. Can we see this? One methyl group is present, one Cl group is present, and on the left hand side one ethyl and hydrogen is present. So for first and the fourth, the optically active isomer is present. Chiral carbon is present. These are the optically active. So are you getting it? First and fourth are optically active. So I can say, I mean, these shows optical isomer also. So how many number of isomer? 2 and 2 will be here. Now 1 for the second one, and again 1 for the fifth one. As we can cancel this third one because it is identical. So 2 plus 1, 3, then again 2, then again plus 1. So total number of a possible product, total number of product in the above reaction will be 6. I hope this is clear to you. So actually the concept of the stereoisomer, optical isomer, is also included here. So moving forward. Fine. So the molar conductivities at infinite dilution. So I'm writing here one by one. I can say this Na2SO4. Okay. Then I can write here K2SO4. Then for the KCl. Then I can write for the HCl. Then HCOONA. For these, the molar conductivity at infinite dilution is the given. For formic acid, I have to calculate by help of these values. I will adjust all these values according to that. I will get the molar conductivity for the formic acid. I hope this is clear to you. So what I can do here, okay, so if I will divide by the 2, suppose, because one sodium is present, you can see in this sodium formate, you can see actually one sodium is present, but here 2 sodium is present. You can see in the potassium sulfate K2SO4, while KCl only single potassium is present. So I will divide it by the 2. So I hope the point is clear. Now I can put here negative sign. So what will happen if I will put here negative sign? So this K will got cancelled and this Cl of HCl will get cancelled. Okay, so I hope this point is clear. Now if I will put negative sign here again for the Na2SO4, we can see this single sodium get cancelled with the sodium formate, and this SO4 sulfate will get cancelled with the K2SO4 one. then I will add here positive sign and then positive sign, then again positive sign. So I hope this point is clear that from given molar conductivity at infinite dilution, we will adjust accordingly so that we can get the molar conductivity of the desired one. So for Na2SO4, the value given is the 260. For K2SO4, it is given 308. For KCl, I can see it is given 150. For HCl, it is given 426. And for the sodium format HCOONA, it is given 105. Fine. So we will just put the negative sign here only. And we can find out the value. We will divide it by the 2. So just we have to solve now. Minus 130. I can say 154. Then I can say I think it will be the minus 150, 426 and 105. We will the 239 plus 426. So only the calculation is left 5. This is 8 and 685. Fine. So 685 here minus 280. It will become 405 Simon and the centimeter square mole inverse. So what I have done, I will just tell you quickly. For all the actually electrolytes, the molar conductivity and infinite dilution is given. We have to find out for the formic acid. We will adjust and rearrange such that we will get the values from there. I will divide this Na2SO4, K2SO4 by 2, and I will add the negative sign so that this sodium and this sodium will get cancelled. This sulfate will get cancelled. The potassium, and even Cl will get cancelled here. So what is left now? Okay. So which part is the left? HCOOH is left. This will just add. So on adding minus 130, minus 50 to become minus 280, we will add these. We will get the 685. The final answer will be the 405. So please check that. Okay. So in the given question, what we have to find out here, 6 mole of the compound is given here. Okay, the 6 mole of the compound A reacted with the axis of the B in the following sequence. So the reaction given is the 2A plus B will gives the C, and then 3C plus 2D. 3C will give the 2D. 34 gram of the D is obtained at end of the reaction. The molar mass of the D we have to find out. Okay. So what we will do here, we can apply here that mole analysis, or by help of that, what we can do with help of that actually, we can find out here. So we can see as per the stoichiometry, this Na by 2 is equals to Nc. It will become just 3 by 2 Nd. If you can see the stoichiometry, so I can write like this. Okay. And then what we can do, we can put the values here as what we used to do in the mole analysis. In the mole analysis, the number of moles which is given and whatever stoichiometry is there that we put in the denominator. Now, sir, why the 3 by 2 is there? It is not given for the 2D, so we will adjust according to that. You can see actually for 2A it is given. Here it is 3C and here it is the C. So what we will do actually, we will simply just adjust here. Okay, so Na by 2 here. And I can write here Nc by 3 and Nd by 2. So this 3 will come here and actually we will get this value by the mole analysis. I hope this is clear to you as per the stoichiometry. Now 6 mole of compound is given and we have to find out for the D. So what we will do, we will equate. I can write Na by 2 will be 3D by 2 Nd. This is the number of moles for the D. This is the number of moles for the A. So total 6 mole is given. I can write 6 by 2 and it will become 3 by 2 of the Nd. So it will just cancel and Nd is equals to 2. So the number of moles for the D will be 2. I hope this is clear. By the mole analysis, we can get the value of the number of D moles. Now, as we know that the number of moles is equals to the given mass upon molar mass. What they are asking the molar mass. So the molar mass is equals to given mass upon moles. Okay. So what is the mass here? Given mass is the 34. Number of moles is equals to 2. So the answer we will get here is the 17. So very simple question this is. Okay. Only the mole analysis we have to do, where the number of moles given we will put in the numerator. In the denominator we will actually put the stoichiometry. For D we have to find, and for A is given, we will just equate the both and we can find out the value. So the answer here will be the 17.00. So yeah, thanks for the watching. I hope it's helped you. Okay, thank you.
Okay. So let us start the discussion. So first question. So if z lies on the argument z minus 1 equal to pi by 4, then we have to find the maximum value of this thing. Okay, sure. So argument of z minus is equal to pi by 4. So what can we say? So that means that tan inverse y by x is equal to pi by 4. Okay, modulus. But again, this is in the first quadrant, so it's fine. So y by x will be equal to 1. Okay, so what is the real value here? If I put here z is equal to x plus iota y, so I'll get the real as x minus 1, and iota part will be, the complex part will be y. So y upon x minus 1 will be equal to 1. Okay, and I'll get y equal to x minus 1. So this is a straight line, this curve. So z is lying in this straight line here, like this, and this point is 1, 0. Okay, and these 2 points, z, you can write it like this: z minus z1, okay, minus z minus z2. Okay, so this z1 is negative 2, 5, so minus 2, 5, this point. Okay, so minus 2, 5, and this point is 0, 5, this z2, 0, 5, this. Okay, so now we have to find, now any arbitrary point P, if you take on this line here, okay, P, so you have to find this distance z minus z1, that is the distance between P and this point A, and again the z minus z2 means P and this point B. So distance will be like this is like PA, and this will be like PB, this will be PB. Okay, so what can we say? Like if we see the triangle also, so we can say this is the line y equal to x minus 1, and triangle we can say that PA must be like less than PB plus AB. Okay, so this is PA, this thing is PA, and this thing is PB. So PA minus PB you will get as AB. This should be less than AB. But now when this triangle, all the 3 points are coincident, no? The triangle is no longer formed. So it will form a straight line like this. With straight line like this. Okay. At that point, you will find the maximum value of PA minus PB. That will be AB only. This length AB. This length AB. And the point P will reach here because P is an arbitrary point. So AB is how much? AB length is 2. This distance is 2. So your answer will be A. So yes, your answer will be A. 2. Okay. Now let us see the second question. So in a large group of people, 400 people, 160 are smokers and non-vegetarian. Okay. So again, see, you can also take this as 3 events. Okay. So name the event first. So A is the event when these are smokers and non-vegetarian. So how will I write? I can write PA. PA basically this thing. Person is a non-vegetarian and a smoker. So PA will be 160 by 400. Okay. This PB will be, PB is what? PB is smoker and vegetarian. So this will be what? 100 by 400. And the last thing will be PC. That will be 140 by 400. Okay. And now the probability that is given. their chances of getting a particular chest disorder. Okay, so event E is getting a chest disorder. Okay, event E I'm defining as getting a chest disorder. So what is the probability of PE by A? That is the getting a chest disorder due to this being a smoker and non-veteran. That will be 35%, 35 by 100. Okay, same thing PE by B will be, this will be 20 by 100, and lastly PE by C, this will be 10 by 100. Okay, so now we have to apply the Bayes theorem. Okay. So let us apply the Bayes theorem. So Bayes theorem is, so smoker and non-veteran. So we will get 160 by 400 into 35 by 100, and then the summation. Okay, 160 by 400 into 35 by 100 plus what is going to 100 by 400 into 20 by 100 plus 140 by 400 into 10 by 100. Okay. So when you will solve this, I think you will get to this thing 28 by 45. Okay, okay, correct. Now the next one. So question number 3. So it is given that function is differentiable. So what does it mean? The function is differentiable, that is one thing, but also it has to be continuous. So first we'll write the equation from the function being continuous at x equal to 3. So at x equal to 3, what is the value of function? The left hand limit will be 3 k into from continuity. Okay, from continuity we can say k into 3 plus 1 root 4, there's 2. 2k should be equal to mx 3x plus 2, 3m plus 2. 2k is equal to 3m plus 2. That is 1. That is equation 1. Now second, from differentiability. So differentiate this. So k 2 root x plus 1. Okay, this is equal to m. Fine. Okay. So from here, what I will get, let me see. So, okay. So you can put here x equal to 3. So you will get k equal to 4m. Okay. And if you put this here, so you will get this. If I put in here, so you will get 8m or 5m equal to, so m equal to 2 by 5. So m I am getting 2 by 5. So I will get k equal to 8 by 5. So m plus k will be 10 by 5, that is 2. Okay, plus k. Okay, now the fourth one. So the range of this function. Okay, so this is again, if you see the denominator, so that is 3 sine theta plus 4 cos theta. Okay, so we know this thing a sine theta plus b cos theta. This ranges between under root a square plus b square, plus and minus under root a square plus b square, and negative times this thing. Okay. So this will range between 5 to minus 5. If I add 2 here, I have to add this side also. So if I add 2, I will get here negative 3 and 4 cos theta plus 2. Here I get 7. Okay. Now I have to reciprocal. If I reciprocal it, the sign will change. So answer will be negative infinity to 1 by 3 minus 1 by 3 union 1 by 7 to infinity. CR. Okay, because if we reciprocal here, now the sign will change. So this thing will be 1 upon 3 sin theta plus 4 cos theta plus 2 will be less than minus 1 by 3 and will be greater than 1 by 7. Okay, so C answer. Next. So question number 5. Okay. So look at it, this question. So what is given here is a line. This thing. A to the points are like the point is A to B, and then direction is lambda times L34, and there's a point given 3, 5, 7, and this is the point 4, 3, 8, and this is the perpendicular. Right, like this point basically. Right, this is the point 3, 5, 7, and this is the perpendicular. So perpendicular means, let's say this is some PQ AB. No, let me take PQ. So what is this PQ vector will be this thing. You can write 3 minus 4, or you can write 4 minus 3, anyway. So I'll write 3 minus 4 minus I cap minus 2 j cap minus 1 k cap. 3 minus 4, 5 minus 3 will be plus 2, sorry, and 7 minus 8 will be again minus 1. So this PQ vector will be perpendicular to direction cosine of this L3 and 4. This will be perpendicular, so the dot product will be 0. So I will get minus L plus 6 minus 4 equal to 0. So I will get L equal to 2. Yeah, I think I'll get L is equal to 2. One second. Okay, so I got L is equal to 2. So L is equal to, okay. So what can we say about this point Q is on this line. This point Q is on this line, and L I got 2. So basically A plus lambda L is equal to 3. 3. PQ you got minus I cap plus 2 j cap minus k cap. Okay. Now this Q point 357 is on this line. So 3 will be equal to A plus lambda L. L is 2. Okay. Similarly, 2 will be equal to this 2 will be equal to, or rather 5. 5 will be equal to 2 plus lambda times 3. So from here I will get lambda equal to 1. I'll get lambda equal to 1. So from here I will get A is equal to 1. Okay. So from here I will get lambda equal to 1. I'll put lambda here, I'll get A equal to 1. Similarly for B, so 7 will be equal to B plus lambda 4. So lambda 1, so B will be 3. So I'll get A1 and B3. A1 and B3. So once you get the A, B and L, you now have this line L1. Okay. Now you have to find the distance between L1 and L2. Okay. So now it is easier. So you have L1. L1 you have A is 1. So 1, 2, 3 plus lambda times L. L is 2. 2, 3, 4. This is L1. And L2 is 2, 4, 5 plus mu times 3, 4, 5. Right. So now we have to find shortest distance. Shortest distance is D. D is equal to B1 cross B2. So B1 cross B2 will be this thing. This ratio. Okay. And into A2 minus A1 dot A2 minus A1. So B2 cross B1 dot A2 minus A1. Right? And we have to divide it by like magnitude of this thing, cross B2 cross B1. Okay, so B2 cross B1 we can find with the help of determinant. So I have here I, J, K, and B2 you can write 3, 4, 5, or B2 you can write, let's say I'll write here 3, 4, 5, and 1, 2, 3, 4. Okay. So how much I'm getting? I cap is my negative 2, 4, 4 is 16. 3, 3, 15 and 16. So minus 1. Minus I cap and J cap 10 minus 12. Minus 2 plus 2. 2 J cap and 8 minus 9 minus K cap. This is the determinant, and the magnitude will be 1 square plus 2 square 4, 5 plus 1 6, root 6. Magnitude will be root 6. So the magnitude will be this thing. This value will be root 6. Okay. So let me write here next. Okay. So magnitude we got. We had B2 cross B1 into A2 minus A1 upon. So this B2 plus B1 we got same thing, minus I cap plus 2 J cap minus K cap upon root 6 and dot with here these two 1 2 3 and 2 4 5. So that you have to subtract. Okay, dot. So you will get I cap plus 2 J cap plus 2 K cap. So now you can dot minus 1 plus 4 minus 2 K cap upon root 6. So you will get 1 by root 6. So distance is again positive. So 1 by root 6 is all good. Okay, so let us solve the next one. Sixth question. So in this question from matrix, so A is non-singular. So determinant A is not equal to 0, and A is given as AB minus BA. AB minus B. So what we can write about AB? AB will be A plus B. So let me write AB is equal to A plus B. Okay. So if you take A common, you will get AB is equal to A plus B plus I. Correct? So B plus I. Okay. Now, if I take the determinant value, determinant will be determinant of AB will be equal to determinant of A into determinant of B plus I. B plus I. So this will be determinant A, determinant B equal to A into B plus I. Okay, now this thing is non-singular A. So determinant A cannot be equal to 0. So from here we got determinant B is equal to determinant B plus I. Okay, now same thing we'll do. We'll start again. Now we'll take. Let us take BA to the left hand side and A to the right hand side. So BA I took to the left hand side and A I took in the right hand side. So here I'll take common again A. So left B minus I and BA. So determinant B, determinant A, same thing. Determinant A, determinant B minus I. So same, I'll get this value equal to this thing. So from equation 1 and 2, determinant B is equal to both these values. This one, B plus I and B minus I. So they are equal. Fine. So seventh question, integration question. So 0 to infinity 6 upon e power 3x 6 times e power 2x plus 11 times e power x plus 6 dx. Okay. So see, basically if you take e power x as some x, capital X, okay, e power x as some capital X, so below is a cubic equation, and it looks like this: x cube plus 6x square, 6x square plus 11x plus 6. It's sort of a cubic equation. So by hit and trial, let us try to find one root of this equation. So if I put -1, so I'll get -1 plus 6 plus 11 plus 6. So 12, 11. Okay, here I'll get minus. Here I'll get minus. Okay, so 12 minus 12 plus 12, so 0. So we have a root of this equation as x plus 1, and x was e power x. So I can write 0 to infinity 6 upon e power x plus 1 multiplied by, no, you can divide also. So let us try to find e power 3x. We can write e power 2x, we'll get e power 3x. For constant, we can multiply by 6. Okay, and to get this 6, so once I'll get from here e power 2x. Okay, so here will be 5 times. Okay. 5 times 5 multiplied. Okay, so this is the factorization. So I think we can factorize this further also. So 0 to infinity 6 upon e power x plus 1 e power x 2 and 3. You can break the middle term. So 2 and 3. Okay, dx. So yeah, we got the factors. Now we can take the help of partial fraction. So partial fraction. So partial fraction will come out to be, let me do partial fraction once again. Sure, here solution is given. We can do partial fraction also. So we have 6 upon e power x plus 1, e power x plus 2, and e power x plus 3. So you can take a upon e power x plus 1, b upon e power x plus 2, and c upon e power x plus 3. So if we take the LCM, we'll get 6 is equal to a times e power x plus 3 into e power x plus 2. Okay. Plus b times e power x plus 3 into e power x plus 1. Okay. Plus c times e power x plus 1 and e power x plus 2. So first, if you put here x equal to, let's say, log 1 by 3, yeah. Now basically we have to make this as 0. Okay, e power x. Now we can substitute with x only. No, we should have done with x. Wait, 1 second. Let us do the help of x on partial fraction. Six by, I will take some capital X plus 1, capital X plus 2, capital X plus 3, equal to a by x plus 1, b by x plus 2, and c by x plus 3. Okay. So here I get 6 a x plus 1, x plus 2, x plus 3. Okay. b x plus 1, x plus 3, and c x plus 1, x plus 2. Okay. So if you put -1, so this term comes with 0, and here will be 6 into -1 plus 3, 2, -1 plus 2, 1. So a we are getting as 3. Okay, so here you can see. Okay, here also 3. They are 6 outside. If you multiply 6, you will get 3 only. Okay? So same thing. So a got 3, so you can write is 3 upon e, this thing. Okay. Similarly, you will get b and c as, we're getting as -6 and plus 3. Okay. Now you can take again same thing, 6 common, so you will get same value, and integrating e power x plus 1. Okay, so you can take e power x common from the denominator, you will get e power minus x upon 1 plus e power minus x. So if you put this numerator denominator as t, you will get dt e power minus x dx as dt. Okay, minus dt you will get. Okay. So then we can integrate 1 by t as ln t. So ln 1 plus e power minus x. Okay. And yeah. Yes, and then we can solve. Okay. So this is e power minus x 1 by x. So if I integrate this, I'll get 3 outside. I get minus ln 1 plus e power x minus x. This goes to 0 to infinity. Same here. 3 is here. So let me hit 6 here. And this minus will become plus because another minus will come. If I take common e power minus x, this will become plus, and this will be ln e power minus x 2 e power minus x plus 1. This also goes from 0 to infinity. Same thing with the third part also. So when you will put, you will get 3 ln 2 minus 3 ln 3 plus ln 4. So answer will be, you can multiply it. This will go to the power, this 3. And this will also go to the power, and we'll get ln 32 by 27. Okay. So 8th question. Okay. So area between the and the vertical asymptote. Okay, vertical asymptote. So let us try to draw the graph. So vertical asymptote means y has to go to infinity. So first let us write the expression for y. So y is equal to a minus x cube whole cube upon a plus x under root. So y has to go to infinity. This means that here denominator should be 0. So denominator will be 0 at x equal to minus a. Okay, and we can see the root. One of the root of this equation is x equal to a, because if I put x equal to a, y will be equal to 0. So this is one of the roots. So the graph will look something like this. Okay? At x equal to minus a, it will go to infinity. Then it will come to 0. Okay? Same with the help minus direction also, same thing. Like this graph. Okay, this is x equal to a. So integration area under the curve, you can find, this is, if I integrate this from negative a to a, so this area will come. Now this is area also bounded, so I can double it to get this area. So 2 times minus a to a, this one, root a minus x cube upon a plus x dx. Okay, now this is area. Now we can use the property f of a plus b minus x, like basically fx dx a to b is equal to f of a plus b minus x dx from a to b. So a plus b will be minus a plus a 0 minus x. So I have to substitute minus x in place of x. So a plus x whole cube upon a minus x. Okay. So let us add both the equations. Okay. So you will add, so you get 2a is equal to 4 times this. So a is equal to 2 times this thing. Okay. So here. So you will add this, you will get a is equal to 2 times integration of minus a to a minus x whole cube upon a plus x plus a minus x, a plus x whole cube upon a minus x. Now if you take the LCM, you will get a minus x power 4, a plus x power 4. The root will get outside. Now you can take the terms out of the root, and you will get 3 pi a square. Okay, when you put this thing limit. Okay. So here, now what is given? Line passing through extremity of major axis. So this is major axis. This is major axis. What is the equation? X square by 9, y square by 1 equal to 1. So this point is 3, 0 and this point is 0, 1. So a line passing through extremity of A of major axis and minor axis. So line will pass through like this. Okay, meets the auxiliary circle. Auxiliary circle's equation will be x square plus y square equal to 9. And this thing. So it will meet here at this point. So it will meet at this point. Okay. So how do we find that point? So this equation of this line is x by 3 plus y by 1 equal to 1. Intercept form. This is the intercept. This. Okay. So this equation of circle is x square plus y square equal to 9. And from here I will have y is equal to 1 minus x by 3. So if you put y here, you will get x square plus 1 minus x by 3 whole square equal to 9. Okay. What is the quadratic that is forming? Let us see. 1 plus x square by 9. Okay. 1 plus x square by 9. And okay. x square by 9 minus 2x by 3 is equal to 9. Okay. So let me solve this quadratic. This will be 10x square by 9 minus 2x by 3 plus 1 will go here there, so minus 8 equal to 0. Equal to 0. So here what will I get x value? So 10x square 9 times minus 6x minus 72 equal to 0. So x value you will get, I think you have to find. Okay, so x value you will get from here minus b minus 6 plus minus b square 36 minus 4ac 720 into 4 plus 1 to a is again 20. So 36 you can take common, you will get 6 outside. 1 plus 36 I have taken common, so 24s are 80 and this will be 9. So 6 plus minus 54 by 20. So if I add, you will get 3 and you will get negative 2 48 2.4 negative 2.4. Okay, negative 2.4. So then the area of APO. Okay, so this area they're asking. So you got this point x as minus 2.4. So this point is minus 2.4 comma. If you put here x value minus 2.4, so you will get minus 0.8, 1.8, 1.8. So this is the point. So this APO, this is P, this is A, this is O, origin. So half base height. Base is 3, height will be 1.8. So half 1.8 into 3. So 0.9, 2.7. Okay. Okay, the curve satisfies the equation dy by dx and passes through this point. Okay, so carefully let us start this one. So I'll cross multiply dy x y cube minus x dy, right? Dy minus x square, maybe, yes, x is equal to xy plus y power 4 into dx. Okay. Now you will write, you can take this y power 4 dx this side, so you will get xy cube dy minus y power 4 dx is equal to dy x square, you can take this side, so x square dy, and you're left with here xy dx. So here if I take y cube common, I'll get x dy minus y dx, and here if I take x common, I'll get y dx plus x dy. Okay, so this one is the product rule, this thing is a product rule, and this thing can be the quotient rule if I have divided by denominator square. If I divide this by the square of denominator, I will get the quotient rule. So divided by x square, maybe, yes, x square. Okay, so this will become x square y cube quotient rule, d of y by x, and here x, and this is product rule, d of x of y, d of x of y. Okay, so now we can xy, you can substitute this side, no? Xy square, no? So you can write this, let's write x square y square, I'll send that side, I'll keep one y here and one x here, this x down, and I have sent x square y square down here, so d of xy into x square y square. Okay, or you can write xy whole square. So now if you integrate, okay, y by x, this is capital X and this is dx. Okay, so integration of x dx will be x square by 2, so y by x 1 by 2, and this is again 1 upon x square, 1 upon capital X square dx. So this will be equal to minus 1 upon xy, because minus 2 plus 1, so plus c. Now it is passing through 4 comma minus 2, so you can put the value 4 comma minus 2, so I think you will get c equal to 0 only. So c is 0, c you will get as 0, and if c is 0, then simply you have y equal to y into y square, y into y square is y cube, and this is equal to minus 2x. Yes, this is C option. Okay, next, 11th. So 11th. Again, this is a simple one. Smallest radius of a circle orthogonally intersect. So it is intersecting orthogonally. So let us assume the circle first. X square plus y square plus 2gx plus 2fy plus c equal to 0. What do I have here? G1, G2. So what is the condition? 2g1, g2 plus 2f1, f2 is equal to c1 plus c2. Okay, so in this, for this one, center is 0. Okay, so simply you can write that c minus 4 is equal to 0. Okay, here the constant will be negative 4 if I take this side, and here the constant is c, and x minus 6 whole square plus y square minus 2. So what is the g1 value here? So the center is 6. Center is 6. So g1 will be minus 6. So 2g minus 6, and f is 0. Okay, because center is in the x-axis. So f will be 0 plus 0 plus equal to c1 plus c2. So c1 is here, the c1 is 2. So here you have to find the c. So this will be x square plus 36 minus 12x plus y square equal to 2. So 34. 34 will be c. With x square minus plus y square minus 12x plus 34 equal to 34 here, and from here the constant is c. So I get g is equal to 34 plus c upon minus 12. 34 plus c I got from here, c I got 4. C is equal to 4 from here. So 38 by minus 12. So minus 19 by 6. So radius will be under root g square plus f square minus c. I know the value of c, I know the value of g. I don't know the value of f, but they're asking smallest. So I can take f to be 0. Okay, for smallest radius, f is 0. And you have g value as minus 19 by 6 and c is equal to 4. So we will get the answer 217 by 6. Okay. Let us move to the next question. Question number 12. Okay, so this function is a continuous function and assumes only rational values. So see, so say it is a function. F0 is 2. F0 is 2. So see, if the function is continuous and only has rational values, so if I move just ahead of x equal to 0 plus h even, it may attain any irrational value if I take the graph upwards or downwards anywhere. Okay, the only way to make this function to have only rational values is to make this function a constant function. So this function is a constant function. So f1 by 2 and like f1 by 2 is 2 only. What is f0? Because it is a constant function. So tan inverse, here I'll write 2 plus here 3 by 2 into 2. Tan inverse 3 by 2 into 2. So again I'll get 3. Tan inverse 2 plus tan inverse 3. So tan inverse x plus tan inverse y. X plus y upon 1 minus xy. So tan inverse minus 1 and that is 3 pi by 4. So this will be the answer. Okay. Great. So this is again system of equation for which the function will possess a non-trivial solution. So what we have to do? We have to simply find the determinant. Okay, so what will be the determinant? Determinant will be 1 minus lambda 3 minus 4, then 1 minus 3 plus lambda 5 3 1 minus lambda. Okay, this determinant should be equal to 0. So I will get 1 minus lambda into lambda plus 3 minus 5. Okay, minus 3 minus lambda minus 15 minus 4 1 plus 3 times 3 plus lambda. Okay, this will be equal to 0. Okay, so the equation that I am getting here will be lambda into lambda plus 1 whole square equal to 0. So lambda will be minus 1 and 0. So how many values? Exactly 2 values. So our option will be B. Okay. So F1 is 7. F1 is 7, F dash 1 is 2, and F double dash 1 is 16. Sorry. So we have to find F inverse of 7. So we have X is equal to G of Y. the inverse function. Let us say f inverse is g. So x equal to g of I. Differentiate both sides. I'll get 1. I'll get g dash y and y dash. So y dash is nothing but f dash x, because y dash is f dash x. Y equal to fx. Y dash is f dash x. So 1 is equal to g dash y into y dash, which is nothing but f dash x. So I get from here g dash y is equal to 1 upon f dash x. Now if I differentiate this, I'll get f dash x whole square into f double dash x. Okay, so g dash 7 I have to find. So for y7, x is 1. So this is f dash 1 upon f dash 1 whole square. So f double dash 1 is 16 and f dash x is 2. So the first thing minus will come 1. Minus 2 square will be 4. Minus 16 by 4 will be minus 4. So answer will be minus 4. Here I think answer is given minus 2. So no, answer will be minus 4. Because here they have done cube. So it will be square. Okay. Here f dash x square. So answer will be minus 4. Okay, how many 6 letters word can be formed using genius? Okay, genius. So of course 720 word letters can be formed, 6 factorial. Okay, 6 factorial can be formed total, such that neither G nor end with S. Okay, so let us find the words that are ending with G, starting with G. So 5 factorial, ending with S, again 5 factorial. Okay, so if I subtract this, both the things, now I have subtracted the words which are starting with G and ending with S twice. So I have to add those things. Okay, this will be 4 factorial, because this is 4 places are left. So I have to add 4 factorial. Like basically add means minus will add 4. So first I subtracted this 5 factorial, and then I will add this 4 factorial. So 720 minus 240 minus 16. So 720 minus 240 will be 360. 520. Okay. So answer will be 504. 5 factorial. Yes. Okay. Okay, acha. Sorry, this is 24 actually. 4 factorial will be 24. Yeah, now it's correct. 504. Okay. So limit 12 power t minus 3 power t. So from 12 power t minus 3 power t minus 4 power t plus 1. So I also want to rationalize this. So I will multiply with 2 cos t plus 7 plus 3 and 2 cos t plus 7 plus 3. And you can see here, you can take from 12t and 3t, you can take common 3t, 3 power t. So rationalization denominator will become a square minus b square. So 2 cos t plus 7 minus 3 square. So 9. So minus 2. And I can write this as here 2 cos t plus 7 plus 3. And I can take 3 power t common. So I'll left with 4 power t minus 1. I can take minus 1 common from here. I left the same thing. So this will be 4 power t minus 1 into 3 power t minus 1 into 2 root cos t plus 3 upon 2 times cos t minus 1. Okay. So t is tending to 0. So if t is tending to 0, I can divide this thing by t. 4 power t minus 1 and 3 power t minus 1. I can divide this by t. So I'll get t minus 1 by t, 4 power t minus 1 by t, and 2 cos t plus 7 plus 3 divided by negative 2. And 1 minus cos t is there, and t square, because I have multiplied, so I have to divide also. So yeah, t square. Okay. So this will become 1. This will become log 3, a power x minus 1 upon x, limit x tends to 0. So t tends to 0. So this will become log 3 into log 4. Okay. Now here we have to see a bit carefully. So if you put cos t as 0, this will become cos 0, 1. So 2 plus 7 will become 9. 3, no, 9 will, root 9 will be 3. So 3 plus 3 will become 6. Okay. And denominator, this will become half. 1 minus cos t upon t square will become half. I think this is not no need. This is no need. This will become half. So half will cancel. So minus 1 will be the denominator. So answer will be 6 times log 3 log 4. Yes. So question number 7. So here we have. So here we can see it's 9, 11, 13. So they are jumping 2. Like we are adding 2. So let us take the tnth term. So tnth term, how will write? We'll write 1 upon let's write n into root n plus 2 plus root n plus 2, or yeah, n plus 2 into root n. We should write, right? So now we have the nth term like this. So I can take common. So what I can take common? I can take root n into root n plus 2 common. So inside I will have root n plus 2. Okay. So then next step will be let us try to split the LCM. We have to make it in 2 terms. Okay. So what can we do? So this thing inside, yeah. Let us try to write like this. Okay. So if I have 1 by 2 outside, inside I have root n minus 1 upon root n plus 2. Okay. So calculate this will be same, root n plus 2 minus root n upon root n into root n plus 2. Right. Okay. So this will come out to be, next page. Yeah. So here 1 by root n minus 1 by root n plus 2. So now we can put the values of n. And n will start from 9 and will go to 36 terms. Okay. So 36 terms will be like, so I got this value 1 by 2, 1 upon root n minus root n plus 2. So this will be 1 by 2 root 9 minus root 11. Okay, the next term will be 1 by 2, 1 by root 11 minus root 1 by 13. Okay, so all the terms will cancel. The last term will remain, that is 1 by 2, 1 by 3, root 9 will become 3, and last term will be, which will be last term. So n is equal to 9 to 36. We are going 9 to 36 term. So first term is 9. So then last term will be, so for the first term, we are using n is equal to 9. So for 36th term, we will use n is equal to, so we'll add, you can add 8 plus 36. No, 40, 44, 40, one second. N is equal to 79. Okay. So So we are skipping 2, 9, 11 like this. Okay, so you can find it like this also, 9, 11 and then 36th term. So we can find with the help of AP also. So A36 will be A1, that is 9 plus n minus 1, 35 into 2. So that will come out to be 79. So we can write here 79. 79 plus 2, that is 81. So root 81 will be 9, and 1 by 3 minus 1 by 9 will be 1 by 3 minus 1 by 9. 9, 3 times 1, 2. 2 by 9. 1 by 2 into, so answer will be 1 by 9. Okay, next 18th. So here you can use the binomial expansion, general term. So question number 18. So your general expansion will be 3 1 by 4 plus 5 1 by 8 power 60. So TR, general term. General term will be TR plus 1. NCR 3 into 1 by 4 power n minus r. So 60 minus r into 5 into 1 by 8 power r. So here will be r itself. So NCR will be how much? 60 CR. Okay, 60 CR. And now we have to find the rational terms. If n is the number of irrational terms. Okay, so irrational terms we have to find. So let us find the first, we'll find the rational terms, and the other remaining all will be the irrational terms. So for irrational terms, so this here 60 minus r by 4. So this I can write as 15 minus r by 4. Okay. So, and here it is r by 8. So whatever number is divisible by 8 will also be divisible by 4. So I don't have to worry about this term, this 3 term. I have to worry about this 5 r by 8. So when r goes to 0 to 60, how many terms will have for which are divisible by 8? 7. So we'll have r is equal to 0, 1, 2, 3 up to 7. So total 8 terms. Okay. So, total terms is, if n is equal to 60, total terms will be 61, n plus 1. And we have here 8 terms which are rational. So other terms are irrational. So see, out of 61 terms, 8 terms are rational. The remaining 53 terms are irrational. So irrational terms is equal to 53. Okay, so here they are saying n minus 1. So 53 minus 1 is 52, and 52 is divisible by 26. 52 is divisible by 26. Okay, so what is given? Function f of x is equal to x cube minus 3a minus 2 x square plus 3x. Okay, this is increasing for in 0 to 1. Okay, so let us try. So this will be a cubic equation. Okay, so we'll have roots. So it is increasing from 0 to 1. So let us find f0. So how much is f0? F0 is equal to 7. So at x equal to 0, function is here. Function is at this point. Now it is increasing in 0 to 1. So we'll go up 0 to 1. Go up. And then from 1 to 5 it is decreasing. Okay, so it means that x equal to 1 is a local maximum. X equal to 1 will be a local maximum. So we have to find fx minus 14 upon x minus 1 whole square. So let us first what we can do. No, we can also find f dash x at x equal to 1 and make it 0 because it is a local maximum. So let us find f dash x. So f dash x will be 3x square minus 6a minus 2x plus 3a. Okay. So this is equal to 0. F dash 1 is 0. At x equal to 1, f dash x is 0. So this will be 3 minus 6 times a minus 2 plus 3. So from here I get the value of a as 5. Okay, so a is equal to 5. So I guess I have the function now. Okay, what will the function? If I put a equal to 5, I will have a function x cube minus 3 times 3, 9x square plus 15x plus 7. Now this is fx. So fx minus 14 No, we can do fx minus 14 upon x minus 1 whole square. So this above equation is the numerator part is the cubic equation. So in cubic equation, how do we find the roots? We have to put x equal to 0, x equal to 1 like this. So let us put x equal to 1. So 1 minus 9 minus 8 plus 15 plus 8 minus 7. X equal to 1. 1 minus 9 plus 15 minus 7. Yes. So yes, 1 minus 9 minus 7, 16. 15 plus 1, 16. So it is 0. Yes. So we can see that x equal to 1 is the one of the root. So how I can write this? 1 second. Okay. So how I can write this? I have x minus 1 as one of the roots. So other root will be x square. Constant term will be 7 only. So x square plus 7 will be the constant term. And the middle term will be minus x square will come from here. So I need 8. Minus x square minus 8. 8x. Right. 15x. Plus 8x and 7x. Yes, this is right. And x minus 1 whole square. Now, again, I think this is a quadratic equation, so we can split the middle term. I think 1 and 7. So x minus 1 into x minus 1 into x minus 7 upon x minus 1 whole square. So this value will come out to be what is given in the question. In the question it is given this value is equal to 0. So x minus 1 this will cancel and x is not equal to 1, so x will be equal to 7. Wait. This is the question. Question number 9. X is equal to 7. Let us start question number 20. So this is here is given an isosceles triangle ABC. Vertex is 6, 1. So 6, 1 is the vertex and isosceles triangle is given to us. So this point B is how much? No, B is not given. So in an isosceles triangle, the vertex is 6, 1. Equation of BC is this. So 2x plus y is equal to 4. Let point B lie on the line this. Okay, it's also okay. So equation of BC is given and B is lying on this point. So B will be the intersection point of these two lines, which is x plus 3y equal to 7. So let us solve. 2x plus y is equal to 4 and I'll write 2x plus 6y is equal to 14. So 2x will get cancelled, 5y will be equal to 10, y will be equal to 2 and x you can write from here 1. So B is 1, 2. So this is B. Now what can we say about C? C is a point in this line, 2x plus y is equal to 4. So I can take C as some x1, y value will be 4 minus 2x1, right? So I will take some x1, 4 minus 2x1. Okay. x1, 4 minus 2x1. Okay, fine. Now C. Okay, now we can say that it is isosceles. So in an isosceles, so I think AB is equal to AC. So length AC is how much? Length AB is how much? 6 minus 1 AB. AB will be root 6 minus 1, so 5 square and 1 square. So this will be root 26. So this is the value of AB. So what will be the value of AC? AC will be also root 26. So we can find AC, that is equal to x1 minus 6 whole square plus 4 minus 2x1 minus 1. So 3 minus 2x1 whole square. So this which is equal to root 26. So we can square both sides. I'll get x1 minus 6 whole square plus 3 minus 2 x1 whole square is equal to 26. So this will become a quadratic equation in x1. So I will get here 4x1 square plus x1 square, so 5x1 square. Okay. Then the constant term will be 36 here, 9 here. So that 36 plus 9 is 45, minus 26 will become 19, plus 19, and middle term minus 12x, and 3 2s are 6 to 12x. So minus 24, 24x1. So from here, if I solve, I'll get x1 equal to minus b plus minus, or I can split the middle term also. Okay, minus b plus minus b square. So 576 minus 4 AC, 20 into 19. So this will be 360. No, 20 into 19. 380. Okay, so upon 10. So 576 minus 380. So 196. 196. So 14. Okay. So from here, one term I'll get 24 minus 14, 10 by 10, that is 1. So x1 is equal to 1, or x1 can be equal to 38 by 10, 19 by 5. So these are two values of x1 I'm getting. So now I have to find the centroid. So centroid is summation x1 by 3 and summation y1 by 3. Okay. So let me find here. So summation x1 by 3. So x1 will be 6, 1, and okay, either 1. Okay, let us find the C point first. X1 equal to 1, then y1 will be equal to 3 by 2. And if x1 is equal to 19 by 5, then y1 will be equal to 38 by 5. 4 minus 38 by 5. 4 minus 18 by 5. Minus 18 by 5. So I'll get the centroid. Centroid I'll get summation 6 plus 1 plus 19 by 5. Okay. And comma. Okay, so I think x1 equal to 1 will be same as the B point, right? X1 is equal to 1. So this line, that point will be 1 comma 2 only. 2x plus y is equal to 4. Yes. So x1 is the B point. So x1 equal to 1 is the B point. So we'll take this value. x1 is equal to 19 by 5. And comma 18. So this is the C, vertex C. So centroid with this divided by 3, and another one will be 1 plus 2 minus 18 by 5 by 3. So this is the centroid, alpha, beta. So we have to find 15 times alpha plus beta. So from here I get alpha 7, 35, 19, 50, 54. Right? So 54 by 15, comma, plus I should write beta. I get 1 plus 2 is 3, 15 minus 3 by 5 minus 3 by 15. Okay. So this will be 51. Okay, 51. Okay, let us do the next one. This question. Okay, so here A, our set A is said to be set of natural numbers less than 6. So we'll start with 1, 2, 3 and go up to 6. So we have 6 elements. Number of elements in set A is 6. What about B? B is again x squared less than 5. So only 2 numbers possible in natural numbers, 1 and 2. So number of elements in B is 2. Then subset of the set A cross A intersection B. So A intersection B you can find out first. That is 1, 2. So we are now making this A cross A intersection B. So A cross A intersection B, here are 6 elements and here are 2 elements. So 1 1 1 1 2 1 3 1 4 1 5 1 6 1, 6 elements like this. Similarly 1 2 2 2 3 2 up to 6 2, 6 elements like this. So total will be 12 elements. So in this set A cross A intersection B, there are number of elements in this is 12, and we have to which contains 3. So we have to find subset. Okay. So firstly we have found that 12 elements are there in the element, and we can take any 3 elements from that 12 to form a subset. So answer will be 12C3. Okay. Next one, 22nd. So here it is given fx is equal to x square 2x plus 6 tan x minus 2 tan square x cos square dx. Okay. So I can write fx is equal to integration x square 2x plus 6 tan x minus 2x tan square x into cos square x dx. Okay. So let us think for a moment, how can we resolve this? So if I multiply this completely and change into sine and cos, what can I get? I'll get x square into 2x cos square x. Okay. Now cos x, tan x, I can write sine x by cos x. So one term will get cancelled, one cos x will get cancelled, and I'll get with sine x and cos x. Okay. And what about this one? Here I'll get 2x sine x only dx. Okay. Okay. Wait, tan x into cos square x, sine x upon cos x. Achha, here I'll get sine square x maybe, because sine square upon cos square x. Yes, here I'll get sine square x. So now I can take common this 2x. I can take common, so I will get x square 2x. I have taken common. Cos square x minus sine square x becomes cos 2x, and another term will be x square 6x square into sine x cos x. So that I can write in 2x form. So 3 sine 2x I should write. So this becomes 3 sine 2x dx. Okay. Now we have to integrate both things. Okay. Okay, 2x into here. So here it will become 2x cubed cos 2x, and this is 3x square sine 2x dx. Okay, so now how can we resolve this thing? So okay, so if we use in this one, in this part here, if we use by parts, so I will take this as this I should take as the first function, and this I'll take second function. So if I take this as the first function, I will keep it as it is, 2x cubed cos 2x, the integration will become sine 2x by 2 minus now integration 6x square, right? 6x square sine 2x by 2 dx, and yeah, here's complete dx. Okay, and the remaining thing here is plus 3x square sine 2x dx. So these two will get cancelled. Okay, these two will get cancelled, and the answer will be 2x cube sine 2x. Answer will be x cube sine 2x. So this is fx. Now they are saying that fx passes through this point, so we can write plus c, and yeah, so c will be 0 because pi comma 0. Yeah, c will be 0, and fx is equal to x cube. Now they have been given fx is equal to x cube. Okay, so x cube sine 2x is equal to x cube. So from here we'll get x cube minus 1 into sine 2x is equal to 0. Now we have to find number of solution for which this thing is possible. So here either x equal to 0, either x equal to 0. Okay, x cube I have taken from, x cube I have taken from, and sine 2x minus 1. So either x cube, either x equal to 0 or sine 2x is equal to 1. So sine 2x equal to 1 in the range 0 to 2 pi. In the 0 to 2 pi, sine 2x is equal to 1 is 2 times at x equal to pi by 4. You know, and at x equal to sine second quadrant, 0 to 2 pi is going, so 2x will go to 0 to 4 pi basically. So we have like this graph, and x is going to 0 to 2 pi, so 2x will go to 0 to 4 pi. So we have two points where sine 2x becomes 1. So from sine 2x equal to 1 we get 2 solution, and from x equal to 0 we get 1 solution. So from here 2 solution, and from here 1 solution. So total will be 3 solutions. Answer will be 3. Yeah, answer is 3. Now question number 23. So in a set of 2n observation, half of them are equal to a alpha, and the remaining are equal to minus alpha. Okay, so let us find a mean x bar. So half basically n by 2 times alpha, and n by 2 times minus alpha, okay, upon n. So basically mean is 0. And what is the formula of standard deviation? Sigma is equal to under root summation xi minus x bar whole square upon 2n, right? So here x bar is 0 because mean is 0. So we are left with summation xi square. Okay, we are left with summation xi square upon 2n. So summation xi square means alpha square, half of alpha square plus alpha square n times. So this will be equal to n alpha square. So answer will come out to be okay, total number of n is 2n. So here actually I should use n times alpha, n by 2 alpha, and here this is 2n times. So I will get 2n alpha square. So I'll get sigma is equal to alpha. Okay, sigma is equal to alpha or mod alpha. So okay, and standard deviation is given as 2. So sigma is equal to 2, therefore modulus alpha is equal to 2. So answer will be 2. Yeah. Okay. So this 24th question. So here we have tan inverse x equal to half tan inverse y equal to 1 by 3 tan inverse z. So basically tan inverse x is equal to pi by 7. Okay. Tan inverse y is equal to 2 pi by 7, and tan inverse z is equal to 3 pi by 7. Okay, so these are the basically x, y, z are the angles. Okay, here I think here it should be 1 by 4. here in the question, it should be not 1 by 3, it should be 1 by 4. Okay, 1 by 4 tan inverse z. So here it will come 4 pi by 7. 4 pi by 7. Okay, not 3, but it should be 4. So I can see that pi by 7 plus 2 pi by 7 plus 4 pi by 7 becomes pi. So these angles, basically, let's say this is some angle A, B, C. So this A plus B plus C, sum of angles is pi. It means that these are the angles of a triangle. So in a triangle, we know if A plus B plus C is equal to pi, we know tan A plus tan B plus tan C. This will be equal to tan A, tan B, tan C. Yes. Okay. So we have to find this thing, half x square plus y square plus z square minus x square plus y square into z square. So x you can write as tan A, y you can write as tan B, and z you can write as tan C. So substituting here, I'll get half tan square A plus tan square B plus tan square C minus tan A, tan B, tan C square. Now in place of tan A, tan B, tan C, this thing, I can write this thing, tan A plus tan B plus tan C. So I'll get half tan square A plus tan square B plus tan square C minus tan A plus tan B plus tan C whole square. That is tan square A, okay, plus tan square B plus tan square C plus 2 tan A tan B, okay, plus 2 tan B tan C and 2 tan C tan A. So this will get cancelled. These three terms will get cancelled. Tan square A, tan square B, tan square C, and half and this 2 will become simple tan A tan B in plus tan B tan C plus tan C tan A. Okay. So this will become this equation. Okay. And yeah, negative sign is also there because of this sign. So negative also there. So negative of, I got tan A tan B plus tan B tan C plus tan C tan A. Now we can change this into sine and cos. So sine A sine B, okay, and then they have taken LCM also. So we can see we have to change this into sine A and cos, and we have to take the LCM. So it will become cos A plus B plus C, and then cos pi will become -1, and remaining is cos A into cos B into cos C. So cos pi by 7, cos 2 pi by 7, and cos 4 pi by 7. This we can find with the help of 2 cos A cos B. Or we can simply do that thing, cos theta into cos 2 theta into cos 4 theta. This is equal to sine 1 upon 2 power n sine theta into sine 2n theta. So we can use this formula to find denominator, and numerator will be cos pi will be -1, and this will cancel out, so this will become 1. So this is turning out to be, this number values turns out to be 1 by 8, -1 by 8. So 8 minus 1, 7. Okay, fine. So here the smallest positive integer for which expression is a negative, and at least one. So here you can see that this is a quadratic equation with a greater than 0. So so the graph, the parabola will be upwards. So upward parabola means it can be like this, or it can touch, or it has to cut at 2 points. So they're asking that the smallest positive integer p for which is negative. It's negative means it has to cut, because here in this case this fx is always positive, the expression is always positive. Here the expression is non-negative. Either it's 0 at one point, but it is non-negative. Only in this case when it has two roots, the function is negative. So basically the function should have two roots. It should cut the x-axis. That means that d should be greater than 0. So d will be how much? B square minus 4ac. So b square means 4p square minus 4ac. This should be greater than 0. So what I'm getting another quadratic equation. 4p square minus 12p plus 16 is greater than 0, or p square minus 3p plus 4 greater than 0. So what are the, we can split the middle term. P, wait, here it will come minus. Here it will come minus. So I'll get p minus 4 and p plus 1 greater than 0. So minus infinity to minus 1 union 4 to infinity. Yes. So the smallest positive integer. So what means the smallest positive integer for which the expression will become negative? So you can see the range of p. So 4 is not included. So positive integer means after 4. So 5. Answer will be 5. Okay, I think we are at the end of the paper. So thank you.